Hello.
Jim, your voice is
Yes,
coming.
ma'am, you
Please
are
begin.
audible now.
Okay, so sorry for the delay caused. Um, Good evening, everyone. Respected Chief Guest, sir, distinguished speakers, honored delegates, and dear participants. It gives me immense pleasure to welcome you all to this prestigious conference. As we have gathered today, we come together with a shared purpose to exchange our ideas, explore innovations, and strengthen collaboration in the field of agriculture. We are truly honored to have with us esteemed personalities who have contributed immensely to this domain. With this, uh, I would like to start the first technical session of National Conference on Agriculture, Innovation, Sustainability, and Leadership for Future India, which is conducted from 26 to 28 February 2026, and today is the second day of this conference. So, for today's session, I would like to invite our chief guest, Professor Sanjay Swami sir, who is Dean of College of Agriculture, Center Agriculture University, Pasighat, Arunachal Pradesh. Sir, we welcome you too on this session.
Okay, thank you, Dr. Shivani. And at the outset, I join Shivani in welcoming all the participant delegates and the team of this 360 Research Foundation who are available on the platform today in this very prestigious national conference on agricultural innovations, sustainability, and leadership for Future India 2026. As the Shivani just has briefed, that this is being organized by the Department of Agriculture 360 Research Foundation in collaboration in association with the SR University Warangal, Telangana. And today is the second day and the second technical session of this conference. This is, I think, first technical session in online mode. So once again, I welcome all the participants. Friends, the Central Agriculture University, our headquarters is located in Imphal, and because this university is mandated to fulfill all the requirements of the farmers for the hill region only. So in northeastern states, we have 8 states where Assam is the almost flatland, where only 2 districts are partially hilly district, and already the Assam Agriculture University as state agriculture university exists there. So the Central Agriculture University, it was established in 1993 with the objective to cater the need of hilly region. And that's why in rest of these 7 northeastern states, we have our campuses. In Tripura, we have College of Fishery. In Sikkim, we have College of Agriculture Engineering and Technology. One more college, new college is College of Horticulture. Likewise, in Meghalaya, we have 3 constituent colleges. One is College of Postgraduate Studies in Agriculture Sciences. Second is College of Community Science. And there is also one UG College of Agriculture Sciences in Meghalaya. Likewise, in uh, this Mizoram, we have College of Veterinary Sciences and one new College of Horticultural Sciences. Likewise, in Arunachal also, we have 2 colleges. One is College of Horticulture and Forestry, and second, where I am heading this college, College of Agriculture, Pasighat. In Imphal, at headquarters, we have also College of Food Science and Technology, and there is also one College of Agriculture. So in every 7 state, we have different campuses, and our mode of admission for the students is through the competitive examination, which is being organized by the Central Agriculture University itself. It is a national level competitive exam, and of course, the 15% seats in PG are being filled by the ICR quota. So this is in nutshell about the Central Agriculture University, and we are progressing a lot under the guidance and able leadership of our Honorable Vice Chancellor Professor Anupam Misra sir. Here in Pasighat, this College of Agriculture have 13 departments, and we have UG as well as PG departments here, and we have many projects which are being run in this campus. So with this background, once again, I welcome all the participants, and of course, I extend my heartiest congratulations and many thanks for inviting me in today's session as chief guest uh, for the this 360 Research Foundation, and especially for the Dr. Vibhava Kumar. So thank you. Now we can proceed for the technical session. So the first presentation is that is invited talk, and it will be delivered by Dr. Sevendra Singh, who is an associate professor at Department of Management Sciences, Mahatma Gandhi Central University, Motihari. So I request Dr. Sevendra to please uh, just brief about him and start his presentation. Dr. Sevendra, please. Dr. Sevendra, can you hear my voice? Are you available on the platform?
Sir is joining, sir. Few seconds,
Okay.
please.
Okay.
Sir is rejoining.
Okay. Okay. No issue.
सर नमस्कार.
Namaskar. Namaskar. So I request Dr. Sivender to share his slides and go ahead with his presentation.
थैंक यू सर. एक्चुअली स्लाइड नहीं है मेरे पास, और मैं
Okay.
आप लोगों का
Okay.
5 से 6 मिनट बस हम लोग एक डिस्कशन कर लेंगे हल्का सा. थैंक यू. फर्स्ट ऑफ ऑल, थैंक यू टू 360 Research Foundation for giving me such an opportunity to interact with the participants, dignitaries of this academic event. एक मैनेजमेंट के टीचर के रूप में मेरे लिए ये एक अच्छा लगा जान के कि एक बिहार जैसे क्षेत्र में कोई इंस्टीट्यूट है जो एक इतने रिलेवेंट टॉपिक पे रिसर्च प्रपोजल्स ले रहे हैं, इतने अच्छे रिसर्च पेपर्स ले रहे हैं, उस पर बातचीत कर रहे हैं. क्योंकि हम सबको पता है कि ये देश एक किसान प्रधान देश है, खेती प्रधान देश है. यहाँ पे आज भी एक बड़ी पॉपुलेशन खेती पे लगी हुई है, और एज अ युवा हमारे पास रोजगार के जो अवसर हैं डेफिनेटली कम होते जा रहे हैं. और एग्रीकल्चर एक ऐसी फील्ड है जहां अभी भी बहुत सारा स्कोप बाकी है। मैं डब्ल्यूएचओ का एक पेपर देख रहा था, तो उसने बताया कि कैसे एग्रीकल्चर में भी एआई का स्कोप बहुत ज्यादा है। बहुत सी टेक्नोलॉजी आज भी, भारत जैसे देश में जहां छोटी जोत है, पैसे का अभाव है किसान के पास, बहुत बड़ा इन्वेस्टमेंट हम नहीं कर सकते, पर एज अ इंडिविजुअल हमारे पास ये स्कोप है कि क्या हम ऐसी टेक्नोलॉजी ला सकते हैं जो उस छोटी जोत पे भी अच्छा प्रोडक्शन दे सके। कैसे हम अपना पर हेक्टेयर प्रोडक्शन इंक्रीज कर सकते हैं। बिहार जैसे प्रदेश में जहां पे आज भी लेबर से बहुत ज्यादा काम हो रहा है, और एक बहुत बड़ा सेगमेंट जो हम देखते हैं सप्लाई चेन मैनेजमेंट का, वो अभी भी बहुत मजबूत नहीं है। किसानों की फसल आज भी खेतों में खराब हो जा रही है, उन्हें मार्केट में प्राइस नहीं मिल पा रहा है। एज स्टूडेंट्स ऑफ एग्री बिजनेस, as a student of management, we should have this opportunity for this state that we could make it more prosperous. Like if you know about the lychee, lychee is a very famous fruit which has very less life span. It comes mid of second week of June, and it will just run by 2 weeks, and after that it perish. And by large 11 month we did not have lychee. So is there any possibility we could make lychee available in the market as a soft drink, as a lychee itself, by cold, of course by cold storage, of course by enhancing our supply chain management system. Secondly, the makhana is also now government is focusing on makhana, and I hope it will fruitful for the farmers of makhana. Beside that, very much you know about the chuda, like rice. It's a type of rice which we people use in having snacks. Chuda is very healthy product, and it also needs to be strengthened the supply chain management of chuda. It could be your superfood for the this generation of healthy food lover individuals. This chuda is a superfood for them also. You can count a number of fruits and vegetables and crops for this. What need, we need a sophisticated research. We need this type of conferences where people give their insights, and these conferences make a report of that, and we will submit it in agriculture department in government of India, so the government could make policy changes. If we talk about only on surface level, we did not make any policy changes. If we need to change the economic viability of this state, economic condition of this state, then we need to do some research, we need to do some practical implication of these research, and make this uh, state more prosperous. And definitely the people here are very much interested in support of government. They are ready to give 24 hours of his or her day for this work. But we need a definitely need support from Bihar government as well as a government of India. So I think this is all about from my side, and I thank you and congratulate the organizers for giving me giving me this opportunity to interact with you all. And if you have any query, any questions from my side, from the how we could manage the agri business, how supply chain management could do we strengthen supply chain management, you can definitely contact me through my email ID, which is shivendra@ngcb.ac.in. I will definitely help you, or you can contact to the organizer and they will contact me. So we hope this conference will be a great success. Fruitful reports, fruitful insight from this conference maybe surface on the floor of the ministries, on the government. And thank you from my side. This is all about my today's little talk with you. Actually, I was a little busy in the education conclave organized by my university, so I could I beg your pardon and request organizers to proceed. Thank you, sir. Thank you so much.
Okay, thank you, Dr. Samandar, for sharing your views. But as a lead speaker or invited speaker, we are eager to listen some key points to improve the agricultural innovation in the existing system. But anyhow, you have shared your views and hope that will work for the participants for their guidance. So next, I was just inquiring whether this Shivani will be taking further this session or I have to take.
Well, I will be
Sir
taking further
Shivani.
the session. Yes,
Okay,
yes.
okay.
Thank you, sir. Thank you for your valuable insights. So, once again, I wish good evening to everyone. With this, we will be welcoming to our technical paper session, and each for this each paper presenter will be given 7 minutes, including discussion. So, first of all, I would like to call Dr. Bhumi for her paper presentation.
Give me two
Dr.
minutes. Ma'am, or else call someone. I'll be ready for the second one.
Okay, fine. Dr. Priyanka. Dr. Priyanka, ma'am, are you there?
Yes, ma'am.
Ma'am, would you like to start your presentation?
Okay, ma'am. Give me a few minutes, ma'am. Good evening, respected chairperson, dignitaries, and guests, and fellow researchers. Today, I am presenting my research work, enter microtaxonomic evolution and sustainable agronomic approaches in family policy for enhanced crop productivity and yield regulation. Um, I request please share my PPT. Can I share my PPT?
Yes, ma'am, you can share your PPT.
Yes.
Okay. Sir, option not visible.
Please check on the screen. If you are joining from laptop, then third option will be share screen option. Else, if you are joining from your phone, then please click on the three dot line, and then you start sharing with the second option
Okay, I
available.
will try now. Option is visible, but desktop PPT not showing this.
Ma'am, you can try share all screen, whole screen option.
Okay, but I have preferred PPT. It's visible.
Not yet, ma'am.
Okay.
Please do one thing. You can share your PPT to Sudhanshu sir or Vibhakar sir.
Okay. Okay.
Ma'am, will you
Even
share by email? Once in a
Yes,
while.
yes, sir. Give me your email.
Okay, I'm writing in chat box.
Okay.
Ma'am, I'm ready. Can I share my screen?
Shivani ma'am, till the time we can allow Bhumi ma'am. Bhumi ready.
okay. Priyanka ma'am, meanwhile you please share your presentation to sir, and I will call Bhumi ma'am for her presentation.
Okay, okay, no problem.
Okay, Bhumi ma'am, you can start sharing your screen.
Yeah, thank you. My screen is visible, right?
Yes.
Yeah, good evening, everyone. So my topic is on geostrategy, water conservation in dry land mines, the synergistic effects of organic mulching and anti-transplant technology. So I have conducted this trial in regions like semi-arid regions, so where the rainfall is less than 450 mm. So in such areas, even though the nutrients are available, due to less moisture percent, the nutrients uptake is very less. So in such areas, the crop growth will be affected. So maize, I have selected. Yeah. Is someone talking?
Priyanka ma'am, please mute yourself. I think your mic is on.
No, ma'am.
So
Okay.
coming to our background, so 70% of the Indian agriculture is related, in which semi-arid regions like Rayalaseema regions, especially in Andhra Pradesh, face moisture stress. So high evaporation leads to yield, reducing yields. So in such areas, we need water conservation strategies like kaolin, which is an anti-transparent, and organic mulches, which are locally available, acts as a evaporation, reducing evaporation. So maize productivity in semi-arid regions is primarily limited by water scarcity, especially in rainfed conditions. So high evaporation and transpiration, which reduces soil moisture availability and also nutrient availability, especially during the critical stages of the crop. So while mulching conserves soil moisture and kaolin reduces leaf transpiration, the combined effect shows a synergistic effect which helps in which helps crop growth, especially in dryland maize systems. So this study evaluates the integrated impact of both organic mulching and kaolin application on growth, yield, water use efficiency, and also economic availability. So maize is one of the most important cereal crops. So we are conducting our research on maize crop. So the material methods we choose is the location is Kadapa, which is located in Rayalaseema region, where it receives 445 mm of rainfall averagely. So I have selected 9 treatments with 3 replications, and then also 4 types of mulch with 2 types of kaolin treatments, which is at 20 and 40 days with 3% of kaolin. And I have selected DKZ 9133, which is a rain-fed maize crop variety. So coming to the plant height, the treatment with T6, which is a coepith organic mulch along with kaolin foliar spray of 20 and 40 days, shows plant height across all the treatments. And also the water efficiency is effectively utilized in a T6 treatment, which is a coepith, and also kaolin foliar spray at 20 and 40 days. And also the grain yield is also the highest in T6 treatment, which is across 6,974 kgs of yield per hectare, which is 54% higher when compared with control. So the net returns also the highest recorded in T6 treatment, which is a coepith application along with kaolin foliar spray, which is 20 and 40 days application. So coming to the both coepith and the dual application, it performed well compared with the paddy straw, groundnut husk, and sugarcane hull. So the yield is 55.7% higher compared with control, and also the effective water utilization was achieved through T6 treatment. So both the integrated soil and canopy moisture conservation improved productivity. So coming to the conclusion, the exceptional highly correlations among all parameters was confirmed in the integrated nature of crop growth and also yield formation, which emphasizes the importance of holistic crop management approaches. These dual strategy water conservation methods offer practical or cost-effective solutions, which is readily adoptable by small farmers using locally available resources. So we have selected locally available mulch materials, which is very less and will be very feasible to the farmers to get those produces. So these findings also contribute to sustainable intensification of rain-fed production systems. So it also provides valuable insights for developing climate-resilient agriculture practices in water-stressed regions. The crop resilience is also very good in such areas if we adopt both organic mulch and also anti-transference. So this technology is very much limited due to, even though the number of unlimited papers are available on this, but both the combined effect strategy is very much limited, and also these both treatments was very much feasible to the farmers and can be adopted by small and marginal farmers, which will be very much feasible and will also impact their yields during the critical stages and also under rain-fed systems. So this future research should focus on long-term sustainability impacts, evaluation under varying rainfall scenarios, and also optimizing for different ecological conditions to further enhance the adoption potential. So thank you.
Thank you, ma'am, for your excellent presentation and for addressing the thought-provoking information.
Yeah, thank you, Shivani Garu.
Bhumi, ma'am, are you ready?
Yeah, just now I have presented. I'm ready, Divyavani.
So sorry, I mean to say, Dr. Priyanka, ma'am, are you ready? Okay, our next presenter is Dr. Arun Kumar Singh, sir. Sir, are you there?
Yes, madam. Yes, madam.
Yes, sir. Please start with your presentation.
Yeah. Good evening. Thank you, Madam Shivani. Myself, Dr. Naurem Arun Kumar Singh. I'm working as a subject matter specialist and I see a research complex for NEH region West Garo is KVK. So I would like to share now my present. There's somebody's, but it's not off. I think the presentation. Okay, I'll just see. Share.
Bhumi ma'am, please. Yeah.
Now is it visible, madam?
Yes, sir. It's visible. Please go ahead.
Yeah. So I will just do the quick. Okay. Good evening. Now is it, where is it? Where is it? Is it visible now, madam? Or where is it? Oh, okay. Now it's coming. Okay, good evening, everyone, chairman, and other participants present in this National Conference on Agriculture Innovation, Sustainability, and Leadership for Future India, organized by Department of 360 Research Foundation, Bihar, in association with SR University. So I'll be presenting my paper on assessment of potassium forms and their relationship with soil physicochemical properties of acid soils under a rice lentil cropping system. So coming to my next slide. It's not going. Madam, next is not going actually. Shall I try once again? Huh?
Yes, sir. Please.
I don't know why the next is not going. I'll just try it again once because it's not going actually. Google Meet is not used to me. Yeah. Is it visible now, madam?
Yes, sir. Yes, sir. It's visible.
Okay. Now, coming to this overview of this presentation, there will be introduction, and these are all self-explanatory statement of the problem. So next, this is the introduction which I am going to highlight for today's presentation. Like potassium, as we all know, that it's a very
Sir,
important.
sir, one
Yes.
second. Please zoom in your slides. Please go in slide presentation mode.
Slide mode.
Yeah, it's
Okay.
not clearly
Okay. Now, is it
visible.
okay?
Yes,
Now
yes,
is
it's
it
fine.
okay?
Yes, yes.
Oh, okay. Actually, okay. Now we have already known that potassium is the third major nutrient after nitrogen and phosphorus, and its deficiency will lead a lot of problem to the crops actually in agriculture sector as well as in horticulture, like lodging problem, yield reductions, and stress tolerance also is there, and the nutrient uptake efficiency will be reduced, and then this pest and disease susceptibility is there. And in the talking about the forms, like we have four forms, and in these non-available forms are mostly dominated in the soil, like 90 to 98%, and the rest 1 to 2% and are mostly available in the form of water-soluble potassium as well as exchangeable potassium. And I have shown here also that how potassium is necessary in rice cultivation in few points as well as in lentil cropping system, because these two crops are very important in Manipur, where the farmers are growing at present very increasingly expanding all the area uh, because it was monocrop, but nowadays because of so many awareness from the line departments as well as from the institutes, it has been increased by the farmers, and that's why a balanced nutrient management is necessary to know the how the potassium works. Because now why the problem is diagnosed here, like we don't a lot of farmers used to like ignore the application of potassium fertilizers, because farmers only knew mostly in this small sector is urea application, and after that they do not even think about application of just phosphorus and the potassium, especially the potassium they ignore. And in the when I just reference one paper, like in the year 2020, the deficit of potassium in Indian agriculture is projected to be around 10 million tons per annum. So this deficit will create a serious nutrient imbalance with major implications on factor productivity as well as in environment. That's why this objective has been taken to study the forms of potassium and their correlation with soil physicochemical properties. These are some few review of literature which I have collected regarding the topic. So just supporting the document of the review of literature, I would like to show the cytometric study about the potassium forms and status studied. Like in the red color, it has been shown about experiment plant height, and then yellow color also some distribution studies like district soils. It is given fertility map and mechanism blue color. And so like in this study, we have collected that in this our global how much in which sector of potassium has been studied so far. It's a brief only, and number of articles which has been cited on soil potassium from the year 1940 to 1924, and which journals has been published on soil potassium more, and which journals are in this range. It's just a brief glimpse of collection of S to support the review of literature, and this is the trending topics of potassium actually. So now my hypothesis is I have already highlighted and how they have interrelated and among the forms of potassium as well as with the soil physicochemical properties. Now the methodology is the experiment was conducted in the College of Agriculture, Central Agriculture University, and from these like one district, Khawal district is there. We have collected 25 bulk samples in random sampling, simple random sampling method. From the rice and lentil cropping system, because now a lot of farmers has been growing there increasingly, as I have already highlighted in the introduction. So but the imbalance and the inadequate fertilization leads to, and moreover the intensive cropping, continuous cropping every year leads to the depletion of this potassium. That's why farmers are not getting much profit or much yield as expected up to the potential yield, estimated yield. So analysis of by following the physicochemical properties like standard protocols, soil properties like texture, pH, EC, organic carbon, NPK, and the CEC and K fractions. So statistical analysis use R Studio, and then Jamovi and Python for visualization. So these are some of the methods which we use in soil parameters, like other methods and the references, and then fractionization also. So coming to the results, like this is the in kg per hectare, the availability of the soils collected from that district, from that 25 soil samples from rice lentil cropping system, water soluble K, as we all know that it's like it's very less as compared to others, because water soluble K will be available in 1 to 2% only, 1 to 5% only, and non-exchangeable is available here this much of like 273.13 kg per hectare, and then non-exchangeable is there. Non-exchangeable will be 688, exchangeable will be 273, lattice will be more, and then this contribution to the total K. So this correlation among the forms of potassium, it shows here that water soluble K has a very strong positive correlations with the other forms of potassium also. Like as we know in this exchangeable potassium, like moderate correlation is there, and that means if it is increase of water solubility is there, then there is an increase of exchangeable potassium also, and that's why some moderate correlation is there, and then but there is a strong correlation among the total K and the lattice K. If we see the exchangeable and non-exchangeable, they have a very really weak correlation, maybe suggesting that the exchangeable and non-exchangeable potassium fractions are not closely related in the data set. So non-exchangeable potassium also strongly correlated with the lattice K as well as total K, and even same like total K is and with non-exchangeable, and lattice K with the non-exchangeable. So coming to the correlation part, this is the most valuable part. Like we have to correlate with the soil physicochemical properties. Here I have highlighted with the red mark like water soluble K with the soil properties, and we have seen here that it is strongly correlated with the ion concentration, that is EC, soil electrical conductivity. Water soluble is most mobile, and readily available in the form of potassium, as we all know. But as its concentration, this water soluble K increases, then the potassium ion, the cation potassium ion dissolved in the soil solution also increases, and it automatically fluctuates or increase to the electrical conductivity. And one factor may be that the potassium acts as a major electrolyte in the soil solution. So coming to these others, I will not highlight. This is the report, strongly correlated part. And like next with exchangeable K, that exchangeable K is negatively correlated with the bulk density, because as we all know that higher exchangeable K will be associated with the better soil structure as well as aggregation. So that means better soil structure or porosity, better porosity as well as better aggregation means the soil compaction will be reduced. That means the bulk density will be reduced. Negatively correlated. It will be negatively correlated because higher exchangeable port K then will be reducing bulk density. And moreover, this clay has a negative soil particles, and then it will, this potassium ion will neutralize it, and then because of this electrical repulsion reduced, then clay particles can come together and make flocculation as well as aggregation. And if we see the pH, like a higher exchangeable K can help to increase the potassium ion, and because it will exchange the hydrogen ion as well as aluminum ion, and it will increase the soil pH. And for acidic soil, it will be coming a little bit increment to the soil pH will be there. So now coming to the non-exchangeable part, I will just sum up like there will be a negative correlation which we have seen in this with the clay, actually clay texture. In this, the strong negative correlation between non-exchangeable clay may be like, suppose clay minerals like elite, vermiculite, and smectite strongly fix potassium ion in non-exchangeable forms. So that means they will trap the potassium ions in their strong interlayer species. The clay content has more surface area, as we all know, and it will be more K fixation. That means you're reducing the amount of potassium in the non-exchangeable port. That's why it is negatively correlated. And as I have mentioned that clay has more surface area than the sill, and now sill fractions will be having lower surface area, and it will automatically whether this one K fixation will be lesser. This is the same reasoning which we have highlighted just now with the lattice K also, and it will be mostly but more tied with the soil mineralogy and the weathering processes. Like in these clay minerals, like highly weathered soils or in the original lattice K, prime like feldspar and mica have already been released, so converted into exchangeable and non-exchangeable. But higher clay content means more secondary minerals, so less remaining lattice K. That's why negatively correlated. And others still is high, as I already mentioned in the previous slide. Also, the same reasoning follows. Total K is, it has been contribution to this, and total K is the mineral K, which is from contributed from the lattice K also, so bound mineral. So it will be same reasoning will follow. So now coming to the conclusion, like in this soil, acidic soil, where we have collected this same this is the forms which have been followed. It is the common like lattices, and then after that, water soluble humus is present, and humus total K is present, and then like there is a need for this strong positive correlations are found in some forms of potassium, but there are non-exchangeable and exchangeable. There is a little bit weak correlation, as well as some other relations are also in negative. So we need to predict that means there is not so much equilibrium in these forms. So with this, I would like to conclude is that this will help the farmers as well as the researchers to predict the ability of the soils to supply K to plants, as well as require for development of sustainable agriculture systems. Thank you very much, madam, for giving me this time.
Thank you so much, sir, for sparking some great points. Moving towards the next presentation is of Rahul Kumar. Rahul Kumar, Mr. Rahul,
Yeah,
are
Ma'am,
you
I am
ma'am.
there?
ready, ma'am.
Yeah, ma'am. Yeah, ma'am. Available. Yes, ma'am. I'm available. I'm just going to share the presentations.
Okay.
Just a moment. Presentation. Give me a moment. I need to put this in presentation mode. Oops. Ma'am, I'm facing some issue. Just give me a minute because it's not in the presentable mode. I hope it's okay,
Okay.
ma'am.
Yes, yes, it's visible.
Okay, so hi, good evening, everyone. So my topic is the green energy and Indian agriculture, because nowadays the demand of green energy, because fossil fuel day by day it's going out and the pricing is going up. So what is the challenge with the diesel? The cost is high, irrigation cost, and the solar irrigation, a lot of benefits. The policy and market, even PM Kushum and a lot of green energy project owned by the government with subsidy and global. If we look at the India, near about the green energy market around 200 gigawatt, and in 2030 it will be 500 gigawatt. So China is leading near about 2000 gigawatt with them, and this is the green energy in India agriculture. Rajasthan is leading. Rest of all I have, Bihar is very less. Maharashtra, Gujarat, Kerala doing good. So solar irrigations and the feeder solarizations, biogas, there is a lot of things. But solar is why, because there is solar panel can work near about 25 to 30 years. So you get solar energy till long time. So some case studies there. So right now, like in India, in agriculture, only 4 gigawatt. If you compare with the total with the 200 gigawatt, only 4 gigawatts. So very less in the clean energy sector. We have government given a lot of subsidy project, but people are not going ahead. So that's why this fossil fuel cost is like diesel cost is increasing. If we install this green energy, we can get a lot of benefits. So some pros and cons. Because if we use green energy, we can reduce the carbon emission cost. There are a lot of things, even for longer time it can work. This is the data, agriculture. Gujarat is leading the 912 megawatt. And Bihar, as per the MNRE website, this is very less, means zero in Bihar. So this is the state-wise solar pump installed mostly in Rajasthan, then Gujarat, then Punjab. Solar pump installed also in the Bihar, I think 1,40,300 pumps. And this is the green energy roadmap from 2025 to 2035, because our government also thinking we have need to reduce the carbon emission, reduce the fossil fuel, because the global climate also change due to the increase of this carbon monoxide, carbon dioxide, because if you use fossil fuel, we have some problem. So these are the metrics from the environment, what we can save: social, environment, social and governance. And if you, here you can see, look at it. If we use the diesel, we 3.8 ton per year and 0 ton per year. This is the CO2 generations if we reduce the using the diesel, and we have optimized lot of cost. So conclusion, green energy benefits, I already explained about that. A lot of benefits, cost, environment, sector, things, even government helping also. So these are things. Thank you. Thank you, team. Thank you, everyone.
Okay, thank you for your engaging and well articulated presentation. So, I shall now proceed to the next presentation.
Ma'am, I am ready.
Okay, Priyanka, ma'am, please start sharing your screen.
Ma'am,
Yes, you can see your presentation if you are ready.
I have shared, ma'am.
It's not visible. Priyanka, ma'am, your screen is not visible. Can you please check once?
Ma'am, I have shared in your email ID.
Okay, you have shared in mail ID. Just
Okay. Can I start, ma'am?
yes,
May I
please go
audible?
ahead, ma'am. Yes, ma'am, please go ahead.
Okay, thank you, ma'am. Good evening, respected chairperson, dignitaries, guests, and fellow researchers. Today, I am presenting my research work entitled Morphotaxonomics. PPT not shown, ma'am. Okay, I will orally present. Entitled Morphotaxonomic Evolution and Sustainable Agronomic Approaches in Family Poaceae for Enhanced Crop Productivity and Weed Regulation. Next, please. What is grass? Grass are green, narrow-leaved, and mostly soft-stem plants that form one of the most important plant families on earth, the Poaceae family. First, was early known as Gramine. Grasses are most beautiful group of monocotyledonous plants, cereals, and grasses. 25% of the vegetations. There are about 10,000 to 11,000 species belonging to 700 genera in the world and 1200 species belonging to the 268 genera in the India. 415 species belong to 125 genera in Maharashtra. It is the fourth largest family of angiosperms. First in economic importance. First rank in economic importance. Next, please. The family Poaceae is one of the most economically significant plant family in the world. It includes major cereals, crops, and fodder grasses. The sustain global food security and livestock production. Next, please. Common plants are there: wheat, rice, barley, oat, corn, and bamboo. These are the inside. Okay, select grass species in the study. I have already told that Trichum sativa wheat, then Oryza sativa rice, then sorghum, then Cyanobacterium. To conduct the morphotaxonomics, evolution of the selected grasses of the species to correlated structure trait of the agronomic performance, to examine crop yields interaction under field condition to suggest the sustainable weed management strategies. These are my objectives. Then, what is methodology? I have morphotaxonomic assessment, agronomic parameters, weed analogies. In details brief were recorded: leaf arrangement, ligule types, inferences pattern, spikelet structure, bloom character, caryopsis, morphology, root system architectures, then plant height, cellular density, biomass accumulation, yield attributes, composition and density of wheat flora, crop wheat comparative interaction, result and discussion. Tractum sativum shows higher cellular density, contribute to effective wheat suspensions. Oryza sativa demonstrated adaptability under the nutrient management conditions. Sorghum exhibits strong root architecture supporting the drought of the tolerance. Cyanodactylion shows the aggressive spreading habit influencing wheat dynamics. The findings indicate the specific morphological traits significantly influence ecological adaptability and crop compression. Then suspendable agronomic approaches, balanced fertilizer applications, timely show and field operations, integrated weed management, reducing and need-based herbaceous usage, ecological method help maintain soil health and reduce excessive chemical dependency. Next, please. Then these are my conclusion. This is investigation highlights the importance of integrating morphotaxonomy, agronomy with science, such and interpreted approaches enhance crop productivity, sustainable weeds regulation, long-term agriculture reliances. Next, please. In conclusion, morphotaxonomic evolution combined with sustainable agronomic practices provide the scientific foundation for the improving productivity and ecological balance in grass-based agroecosystems. Next, please. Grass feed not only animals, they feed human too. Next. Next. You show that. Next, please. Thank you.
Thank you, ma'am, for sharing your expertise. Our one of participant has some query. I saw some message flashing. If you have any queries, please ask. Okay, fine.
Yeah, there is
Now,
a query.
Yes, yes, please ask. Priyanka ma'am, are you there?
Okay, I wrote in the chat box. Maybe she can later answer.
Okay, all right, sir.
Okay,
Thank you.
sir. Okay, no problem.
Now, moving forward with our session, I would like to call our next and the last oral presentation. So, Pasvi Agrawal, Miss Pasvi Agrawal, are you there? Ma'am, please share your presentation if you are available. Pasvi Agrawal. I think she is not available. With this, I would like to start the post presentation session. And the next presenter is Rajesh Shi. Please go ahead with your presentation. Rajesh C from US, Bangalore. Shivam Kumar Rajput. Shivam Kumar Rajput from IAHR. Are you available? Mr. Shivam. Okay. Miss Rupali. Miss Rupali Kosti, are you there?
Yes, ma'am, I'm here.
Yes, ma'am. Please go ahead with your presentation.
Okay, wait for a minute, ma'am.
I think the previous participants are not there.
It is visible.
Yes, ma'am, it's visible.
Ma'am, good evening to everyone. Myself, Rupali Ghosti. I'm a PhD scholar in Department of Horticulture in College of Agriculture, JNKV, Jabalpur. This is my master's research presentation. I'm presenting in a poster form. The research title is Combined Influence of Leaf Scrap Amendment and Humic Acid Seed Priming on Germination of Acid Line, which is Citrus aurantifolia single. I have conducted my experiment in the duration of 5 months, which is 150 days, in the Farm Fruit Research Center, Imalia, which is situated in Jabalpur. I have taken the 13 treatments, which consist of 3 different leaf scrap, which are mango, sapota, and karonda, and seed treatment. Humic acid is a seed treatment with 2 different concentrations, 1500 ppm and 2000 ppm. For this, I have soaked them. For seed treatment, I have soaked the seeds for 24 hours with the 1.5 milligrams and 2 milligram of humic acid in 1 liter of water. The poster presents the six parameters, which are days taken towards germination, days taken to 50% germination, and days taken to and germination percent, seedling vigor index 1 and seedling vigor index 2. And the last is survival percentage. As you see in the graph clearly shows that the control, which is T1, shows the higher rate or higher numbers, as it shows that the earliest germination was like, is somebody saying something? Ma'am, is it somebody saying anything?
No, continue, please.
No,
Continue.
please.
As result clearly shows that the treatment 3, which is soil plus leaf scrap of mango at 100 grams and humic acid 2000 ppm, shows the best results in overall, as it shows that the early germination and the 50% germination was completed in 19 days, and overall the germination percent was the highest in the overall among the overall treatments. Similarly, the seedling vigor 1 and seedling vigor 2 shows the highest or the maximum result in the mango scrap, as mango leaves. I can support this result, or I can so justify is by using the different review papers that shows the mango leaf have different antioxidants properties and phenolic compounds which help to germinate the seed, and humic acid used in higher concentration shows that as the seed coat of citrus is very hard, humic acid helps the seed coat to break seed coat and seed coat and help the early germination. Acid humic acid also helps to increase the soil properties and soil fertility. Humic acid also helps in the early germination. That's why the results are clearly showing that the humic acid and the combination of mango leaves are considered best over all other treatments. Thank you for listening me. This is from my side.
Thank you.
Any questions? I'm willing to answer if there is any question. I hope there is no question. Thank you for my.
If any participant is having queries, please feel free to ask. Ms. Rupali.
Ma'am? Ma'am, I think nobody is having any questions. Please continue
Yes.
forward.
Yes. Okay, now I would like to call Mr. Nitish from University of Agricultural Sciences. Mr. Nitish, please share your screen. Okay, may I now call upon Mr. Pawan to deliver his presentation? Mr. Pawan,
Yes, ma'am. Yes, ma'am.
yes, please start sharing your presentation.
Hello,
Yes,
ma'am. My screen is visible.
but your slide is not visible.
Okay, okay, ma'am. Now it's okay.
Yes, please share in slideshow mode.
Yeah, yeah, ma'am.
Ma'am, now it's visible.
Yes, it's clearly visible.
Thank you, ma'am. So, a very good evening to one and all, and warm welcome to my poster presentation on the topic of agri startup ecosystem, a landscape, performance, and determinants. So, before introducing the startups, I want to introduce what a startup is. So, defining a startup, it should have any business organization to say a startup, it should have at least 3 components. First, it should have a business idea. Second, the business idea should have an innovative component either in the product or service or anything which is going to deliver. Third, it should have a growth potential. So if any business organization having these 3 components, then only we will say a startup. So in our India, the basic problem is there is no uniform definition of the startup. So we attempt to identify, we formulated this study in the 3 objectives. First, to identify the performance determinants of the startups. Second, to landscape the startup scenario in India. Third, how we can get success in our startups. So this is the scenario of our agribusiness startups. I have calculated in 2021 during my master research. So in our India, currently we having more than 2.1 lakh startups registered at the Department of Promotion of Industry and Internal Trade. But the problem is many startups, like daily more than 100 startups is registering at the DPIIT, but only few, like 1.1% startup is getting success. Then what is the problem? So and how we can define the performance of startups? How we can say whether a startup is performing or not? So to say a startup is performing, we classify the criteria into the 3 criteria. First, to say any startup to a performing, it should have a growth rate of more year-on-year growth in the revenue should be more than 25 to 35%. 25 to 30%. Second, to say a startup is performing, it should have the retention percentage of the customer more than 40 to 60%. Third, the year-on-year revenue growth should be more than 25%. Then only we will say a startup is performing. The third was, what are the major factors which are affecting the startup performance? So to classify the startup's performance, to identify the startup performance, we classify this factor into 3 criteria. First is the interpersonal factor, second is the organizational, and third is the external. So organizational and interpersonal factor are under the control of the business co-founder. So co-founder can control this factor, while the external factor related to the policy, market, competitor, and the customer base, which are not directly controlled by the co-founders. So what factor are majorly affecting the startup's performance? So the first foremost, to get the success in any business organization, the prime factor is our product market fit. How our product is satisfying the customers, how we are solving the problems of our customers, how we are understanding the problems of customers, then only we can deliver our product to the market. Coming to the problems of the startups, like many startups comes with the many ideas, but they are not able to get the success in the business, because what is the problem? Whether the ecosystem is not good, whether they are not coming at the right time in the market, whether their product is not good, or the competition is very high. No, absolutely the thing is, the product are coming with the prototype, but they are not having much idea about the market size. They don't have research on the market. They don't know what is the exact problem of our customer. So to get success in any business idea, first we should know what is the problem of our customers. And second problem is many like to incubate the student-based startup. Students are saying, sir, when we should start our business in the market. So the prime thing is, before starting any business, you should collect the comprehensive information about your customers, about your product, and how you can solve the problems of your customers. Second is how to grow and how to establish our business in the dynamic market. So to establish our startup in the business market, we need to generate the customer confidence. And how we can generate the customer confidence? So to generate the customer confidence, our product should be fit based on the problem of our customers. Because in many studies we are studying, like, our good satisfied customer is the best advertiser. So if we are satisfying the customers, then they will act as our promoters. Third is, what should a co-founder do when the startup has to get the product market fit? So to get the product market fit, first is identify the potential of the market. Second, expand the business with the highest investment. Third, go for the diversification if the core business has been already established with the significant growth rate. The fourth problem is what to do under the financial constraint, because all the startups won't able to generate the revenue at the initial stages. So there are many schemes under which we can generate the funds, or we can get the grants. So Startup India has started. Government of India has launched various schemes like Stand Up India, Startup India Seed Fund Scheme. So under the Startup India Seed Fund scheme, any business organization is coming with the a business idea, he can get up to the 5 lakh rupees, while a business idea is coming with the product, then they can get up 5 lakh to 25 lakh under the Upja scheme. So there are other schemes also, but there is not like, if many co-founders say, can we survive with the without financial support? The thing is that to sustain in any startup ecosystem, we don't require the external financial sources. If our product is satisfying the customer, then we can generate revenue and we can sustain. So we should not think like if we having the external funding sources, then only we can success. So this was my prime poster. If you are having any question regarding the startups, you please ask me. Thank you.
Thank you,
And
Pawan.
this poster has been presented at the Bharat Mandapam, and this poster has been already partially published at the Bharat Mandapam. This Q&A has been taken by the Ministry of Department of Promotion and Industry and Internal Trade.
We appreciate your valuable contribution, Pawan. Thank you for presenting your research so clearly. I now invite Dr. Chandrakant.
Excuse me. Hello, madam.
Yes, sir. Hello.
Can we have one question to Pawan? Can I have one question to Pawan?
Yes, sir. Yes, sir. Please, sir.
Sure.
Actually, this is this okay that we can ask questions?
Yes, sir. Yes, sir. Please, sir.
Oh. Like for startup, how can you validate, how by how technique, or by any tools, or by any procedures, how you can validate the demand?
Sorry, sir. Please repeat, sir. Some noise was here in my
Actually, for investing, or for doing any startups, or for starting a business, how by which tool, or by how you can validate the demand of the consumers?
Okay, sir. Sir, demand, basically we can estimate various demand forecasting models are there. In the market, we can conduct the customer survey. So based on the customer survey, we can use the various model like demand forecasting techniques, AIDS model, LES model. That model also we can use for the forecasting the market demand. So based on the customer's perception, how
that will
they
be
are
randomly selected, or
for the selecting the
that model depends on the selection of randomly business persons, or it will be like a selection mode? How it will be the selection mode?
Selecting the customers depend on in which segment you are going to deliver your product. Like if you are delivering to a niche segment, then you should select only this targeted customer while going for the survey.
Okay, identified.
Yes, sir. And qualitative, to analyze the qualitative data, we can use NVIVO 14 software for the qualitative data.
Okay.
Yes, sir. And one advanced thing is that, sir, in NVIVO 14, one problem is that NVIVO is not giving the validation of our data, whether the data is significant or not. That is giving only the only answers of our question based on the qualitative data. So to validate this and that data, one Atlas TI software is there. In Atlas TI software, we are getting the level of the significance, while in NVIVO 14 we are not getting the level of significance. So it's better to go for the Atlas TI software. So step by step is first go to the niche segment, collect the data from our targeted customer in which we are going to deliver our product or services, and then go for the go with the qualitative data in the Atlas TI software.
Okay.
Okay, sir. Thank you, sir.
Thank you.
I want to add one more thing, sir. जो demand है ना, if you want to see international demand, then you can go on trade.in website. Here you on that website you can see like how much your product is consumed in that country. So on basis of that you can trade according to that, or you can produce your product.
Sir, can I add something? Hello? Hello? I'm audible, sir. Hello?
Yes, audible. Audible.
Sir, but the problem with the startup is many startup is coming only with the idea, then how they can estimate their demand? Because at the international level also we can't predict our demand. So to predict that demand, we have to go for only the survey. So to after analyzing the qualitative survey, we can estimate the market demand and formulate our product based on the market. Because at initial stage we are coming up with our.
I think baseline survey will be the best option.
Yeah, right, sir.
Yeah.
Okay, thank you, sir.
Okay, once again, I thank you, Mr. Pawan, for his insightful presentation.
Thank you.
Now, let's move ahead with Dr. Chandrakant and his presentation. Dr. Chandrakant. Okay, I think he's not there. I now invite Ms. Bharti Sa SM.
Yes, ma'am.
To share his... Yeah, please begin your presentation.
Ma'am, is this visible now? Hello.
Yes, it's visible.
Okay. Good evening, everyone. Myself, Bhartisha SM, a PhD scholar from Department of Agronomy in University of Agricultural Sciences, Telangana. And my poster entitled Remote Sensing and GIS-based Delineation of Salt Affected on Waterlogged Soils in the Ghataprabha Command Area. And it was a part of my master's research. And coming to introduction, the salinity and waterlogging are the major hazards in the irrigated agriculture, especially under the arid climates, where the irrigation water is used intensively, and that will cause it to degrade to soil health, reduce the crop yields, and threaten the sustainability. In India, total 8.1 million hectares of land was salt affected, and from Karnataka, it is along 1.5 lakh hectares. And we all know the remote sensing and GIS are proven tools for detecting, monitoring, and mapping for salt affected soils efficiently because of the synoptic and repetitive coverage. And according to the ASPA and his co-workers in the year 2018, they demonstrated there is a strong correlation between the spectral indices and ECE, that is electrical conductivity of a soil, for mapping salinity and in irrigated lands. And coming to the objective, the only objective is to assess the soil salinity and waterlogging using spectral indices derived from sentinel to satellite imagery in Ghataprabha Command Area. Coming to the study area, the study was conducted in the salt-affected regions of Ghataprabha Command Area, situated in the Krishna River basin, across the parts of Belagavi and Bagalkot districts of Karnataka, India. Here I am totally derived the 12 spectral indices. Totally, I derived the 12 spectral indices, which includes NDVI. The NDVI is a index which measures the health of the vegetation. In this study, the NDVI values was decreases as the EC levels were increases, because the salinity will affect the crop, nutrient uptake and water uptake, and overall it will affect the health of the crop. And the salinity, that is SASI, that is salt affected salinity index, soil adjusted salinity index. Here this index measures how best the soil is adjusted to the salinity. Here the values are decreases because at very low levels of soil, the soil will adjust very well to salinity, but as the salinity levels are increases, the soil will not able to adjust to the salinity. And next index is normalized difference water index, and it will measure the water logging. As the water stagnation increases in the soil surface, it leads to the water logging and will occur, and later it will lead to salinity of the soil. And salinity index 1, it is also a salinity index. As the salinity increases, the index value is increases. And in the graphs, there are NDSI, that is normalized difference salinity index. It is also how the crop affected by the salinity, and it is exactly opposite to the normalized difference vegetation index, that is NDVI. And RVI, it is also a vegetation index. The vegetation health was decreases with increase in the salinity. As the salinity level increases, the RVI index is values decreases. And SAVI, it is also a vegetation index, and EVI is also a vegetation index, and CSI is a canopy salinity index or crop salinity index. It is how the crop will gets affected, especially in the clay soils. Hence, the Ghataprabha comment area, the most of the area is a deep cotton black cotton soils where the clay content is more. Hence, I chosen this index. And coming to the SBA, that is soil brightness index. This index measures how brightness the soil, means how salinity affects the soil. It is how the soil was encrusted in the layer of the soil. And more the salinity, the brightness of the soil is more when we capture through the satellite image. And the salinity index and salinity index 2, these are also salinity indexes. And coming to the overall discussion, all the values of vegetation indexes were decreases with increase in the salinity, and all the salinity indices were values are increases with increase in the salinity. And coming to the summary and conclusion of this poster, the vegetation indices shows the negative correlation with the salinity, that is EC levels, and all these salinity indices were shows the positive correlation with the EC levels. Thank you. Thank you for giving me opportunity this time. Is there any questions? I'm ready to answer.
Thank you, Bharti sir, for your valuable presentation. If any participants have queries, please feel free to ask. Bharti Shah is ready to answer. Okay. The next
Madam
presentation.
Shivani,
Yes, sir.
we could not see, I don't know, my network is weak or what. I could not see any slide this presentation while presenting by anybody. So you can see or what, madam? Poster?
Yes, it was
Actually,
visible.
I could not see in my desktop. Okay. Okay, then maybe because of this one. Network.
Still is available on the screen. You can see or not, sir?
The presenter I have seen, but the slide I could not see actually.
Okay, it's actually
The presenter
supposed
is
to
there, the
presentation,
slide
so
is,
only one slide is
the
there.
slide.
Now also Bharti
Respected
sir.
sir, please be in
Okay.
network area and rejoin the session. Okay. I think due to network
Okay.
problem, you are not able to see.
Okay.
And I request Shivani ma'am, you can continue the session for the next participant.
Okay, our next presenter is Mr. Kalluri Parveen.
Yes, I am ready. Can I share?
Yes, sir. Please go ahead.
Which micro window? Enter screen. Enter screen. Hello, is it visible? My screen. Hello, visible or not? My screen.
No, sir, not yet. Yes, sir, it's visible.
Now.
Yes, please share in slide, Sumu.
Now it is visible or not, ma'am?
Yes, yes, it's visible.
Okay. Okay, my name is Kalluri Praveen. I am from College of Agriculture in JNKV Jabalpur. My topic is economic evaluation of battery operated leafy vegetable harvester. Now this poster explain about just economic evaluation. Actually, we developed a battery operated leafy vegetable harvester in my PhD in my research work. First of all, leafy vegetable crops are such as coriander, fenugreek, and spinach are highly acceptable and require timely harvesting to maintain quality of market value. Generally, leafy vegetable leafy vegetable are harvested by manually because due to the manual harvesting of leaf vegetable, people are generally human fatigue and they less efficiency due to the unable to work continuously. Because of that reason, we developed battery operator leafy vegetable harvester. It's eco-friendly and pollution-free and human-friendly. And the design also ergonomic friendly harvester. So present in this presentation only economic evaluation. We already that harvester tested on the three crops, coriander and fenugreek and spinach. That is work very well. So the materials and methods required for this economic evaluation is the major operational cost was estimated by fixed and variable cost. In the fixed cost, depreciation and interest and housing. In variable cost, battery charging and labor and maintenance. Field tests were conducted on coriander, fenugreek, and spinach crops under actual field conditions. The performance of the machine was compared with the manual harvesting also. Key parameters evaluator, cost of harvesting, time required, and economic indicators are break-even point, cost benefit ratio, and break-even point, payback period. The results of the economic results of the harvester is capital cost of the machine is 61,000 and total cost of harvesting is 102 rupees per hour and break-even point 450 rupees 450 hours per year. And payback period 2.94, benefit cost is 39.04, cost reduction 95 to 96% compared with the human method. It's saved at 96%, more than 96% of the time, and cost reduction more than 95 to 95%, and time also saving more than 96%. This is the specifications of developed battery leafy vegetable. Actual field capacity 0.131 hectares per hour. And theoretical field capacity 0.16, field efficiency 81 to 85% based on the different crops. And cutting efficiency 98.2%, conveying loss 0.96%, harvesting efficiency 97.2%. The labor requirement for the work with the developer harvester is 2. And width of the operation 1000 mm. Because of the cutter bar used for the developing of harvester is 1 meter length cutter bar. Cost of machine and weight of the machine nearly 100 kgs. Total operating cost is 39 rupees per hectare. This image shows the specification. This image is the developed battery operator harvester. Okay. Hello.
Yes, hello.
This is the developed battery operator leafy vegetable harvester. Can I show video?
Yes, please go ahead.
This is the harvester. Tested in coriander crop. This is the presently the harvester is moving in coriander crop. Back side is the fenugreek crop. Is it visible?
Yes, yes, it's visible.
thank you. Over any questions?
Thank you, Mr. Praveen, for your insightful presentation.
Okay, thank you.
Sir, I have a question regarding this harvester.
Okay, tell me.
Sir, it is harvested in the first duration as coriander is harvested in different stages in different picking are there.
No,
Does
no.
it
Only
affect the bottom or the collar region of the coriander?
what are the?
बेसिकली जो हम कोरिएंडर हार्वेस्ट करते हैं वो 4-5 स्टेज में हार्वेस्ट होता है. पहली पिकिंग, सेकंड पिकिंग, थर्ड पिकिंग, सीड स्टेज तक जाता है. तो जब हम इससे हार्वेस्ट कर रहे हैं तो क्या नीचे का जो कॉलर एरिया है, रूट जोन एरिया जो है उसका वो इफेक्ट हो जाएगा इससे या फिर वो सेफ गार्ड रहेगा नेक्स्ट पिकिंग के लिए?
Madam, this harvester is working for more than 1 feet height crops only. More than 1 feet means not more than 2 feet, 1 to 2 feet. The height required for because of that front is the reel is there. The reel is only sufficient for 1 meter, and because of using of this harvester, we generally coriander is harvested by with root. But using of this harvester, we can grow again. Using of fertilizer, proper fertilizers and proper irrigation, we can grow again and again. And using of that crop stalks also helpful for soil fertility and provide protect from soil erosion. Major benefit is the we need this harvest is cut the more than 5 centimeters from the land. So this is save the time also. Due to the the seed grow up to 5 centimeters takes some time. That saving the time and reduce the seeds cost also 3 times.
Thank you, sir.
Sir, I have another question.
Tell me.
Hello, sir. I have another question. While we are harvesting this leafy vegetable, what about the weeds, sir?
We need to compulsory. We need to remove weeds before the harvest, sir. Compulsory, we need to remove.
Otherwise, it again harvest that weed also. I think so.
Otherwise, problems. Compulsory before the using of this harvester, we need to compulsory remove weeds.
Okay, okay. Thank you.
Before
Very nice
using
presentation, sir.
Okay.
Very, very impressive presentation.
Okay, thank you so much.
Once again, thank you. I sincerely appreciate the depth and clarity you brought to the subject. Okay. If any participant is remaining from the previous session, once I will call out the name, Rajesh, Mr. Shivam, Mr. Jeevan, Ms. Parshvi Agarwal. If any of you want to present, please raise your hand. Else I will move to the next session. Okay. Now I would like to welcome you all to the second technical paper presentation session. Before starting the presentation session, we have some invited speakers, and I would like to call our chief guest, Dr. Ravi Gopal sir. Dr. Ravi Gopal sir.
Ma'am, he will join in 5 to 7 minutes.
Okay, sir.
So we can take one presentation, uh, anyone if possible.
Dr. Sunil sir. Dr. Sunil sir. Okay, moving towards the presentation, I would like to call our first presenter, Dr. Arun Kumar Das from KVK Meghalaya. Dr. Tarun. Okay, I can see one of our invited speaker, Dr. Manju Latha.
Yeah, I am here.
Sir, you want to
Yeah, I can
begin?
deliver now.
Yeah,
Yeah.
please go ahead.
Can I share the slides?
Yes, sir. Sure.
Whether my slides are visible, madam?
Yes, sir, it's visible.
Is the slides are in on slideshow mode?
Not yet, sir.
Can I stop sharing and redo sharing again?
Yes, please.
Hello, whether I am audible, madam? Hello.
Yes, sir. Yes, sir.
Slides
Yes,
are
sir.
visible, madam?
Yes, sir.
I'm audible.
Yes, sir.
Yeah, whether
Audible
on
and
slideshow
visible,
mode?
sir.
Hello.
Yes, sir. You are audible.
Can I present, madam?
Audible, sir, audible.
Yeah.
Kindly slideshow mode, sir.
Okay. That's a problem. It's not getting. It's a showing sharing only.
Right side down, there is one button nearby the showing the battery percentage, the zoom percentage 68. No, there you
Yeah.
please click, sir. The 68% nearby there. One button is.
Yeah.
Please click there.
Yes, sir. Please click there.
Sir, just try to share full screen.
Yeah, that's not taking. Yeah, that's a problem. I'm trying to share that.
So else press shift plus
Can I
F5.
send the slides?
Sir, we have to take at least 20-minute break.
Okay.
I just came out from my office. I'm just
Okay.
waiting.
Can I send the shares slides to Shubhamshu WhatsApp?
Yes, sir. You can share through mail.
Okay.
Will present.
Because something is. I have sent the slides to WhatsApp through WhatsApp, Shubhamshu.
Okay, sir.
Yeah.
Trying. Excuse me, sir. It
Yeah.
is not happening. Can you give me 30 minute, 20 to 30 minute?
Okay. Okay.
I'll reach in office once again, and then we'll connect, sir.
Okay.
Till the time we can go ahead with next speaker
Yeah. Yeah.
or
Sure.
chief guest, sir. And just after one or two presentations, sir, I'll be there and
Yeah.
will present your slides, sir.
Yeah. 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 Sure. Sure. Sure.
Thank you so much. Thank you for understanding, sir.
Yeah.
Shivani ma'am, are you there?
Yes, sir. Yes, sir.
Maybe sir has joined.
Okay.
You can ask.
Yes, sir. I saw. Ravi Gopal, sir. I think our chief guest, Dr. Ravi Gopal Singh, sir, has joined. Ravi Gopal, sir.
Can you
Yes,
hear
sir.
me?
Yes,
Hello,
sir.
hello.
Thank you
I'm
for
ready with my
joining us.
presentation and please let me. An honor, absolutely an honor and pleasure being with you.
Yes, sir. Please go ahead with your presentation if you have.
Okay. Okay. Excellencies, this is Ravi Gopal Singh. I'm thankful for the Sudhanshu ji for giving me this opportunity to share some of my takes on sustainable food production systems. My name is Ravi Gopal. As you can see, I have been serving different institutions. I served Bihar Agricultural University as Director of Research, the International Center for Wheat and Maize Improvement, as Coordinator for Delivery and Adaptive Research in Latin America, as Principal Scientist with Ricarda, as Scientific Lead for BISA. So I have worked in many countries in different continents, including Americas, Africa, and different parts of Asia. And I'm not going to give you a long lecture, but share some of the examples for sustainable production system. And if you have any question, please let me know. You know, the population is rising and the business as usual in food production cannot feed the growing population, especially in countries like Africa and South Asia. And India is now biggest, most populated country, and therefore the demand for food is growing and increasing, and similarly for the natural resources. Now, this is an example from Mexico, northern part of Mexico. We call it Sonora Valley. And what we have observed that farmers tend to use more quantities of nitrogen for growing wheat and maize. And average consumption of nitrogen on per hectare basis has increased from 40 kilograms per hectare to now 300 kilograms per hectare. And this is mainly because of reducing organic matter content, which is reducing from 4 to less than 1%, less than 0.5%, and also reducing hydraulic conductivity. So the modern agriculture which hugely depends on nutrients and irrigation and fertilizer, has created compaction, and which is affecting the hydraulic conductivity in as a matter, and also reducing organic matter. As a result, farmers tend to apply more water, and farmers tend to apply more nitrogen to offset the ill effect of commercial agriculture. And so there are serious concerns on degrading soil health and natural resources. Now, looking back in the most of this region, where now we have a new problem on top of commercial agriculture, which is crop residue burning. And Punjab was leading this game, but now we are seeing that more residue burning is coming, and non-rice wheat states or out of Indo-Gangetic plains, now Madhya Pradesh is second largest emitter. So farmers tend to, burn crop residues, which is not a healthy practice. And this practice of burning residues increasing day by day, mainly because of absence of livestock farms in the region. And so if you see in Bihar, farmers still use a lot of crop residues as a animal feed, but not in Punjab or Haryana, and therefore they are burning those residue, and as a result of that, farmers are using more fertilizers here in India as well, and the nitrogen use efficiency is declining, and consumption of fertilizer is increasing, in this part of the world as well, which is really an alarming situation. Now, going back to Mexico, I talked to my friends and co-workers. For example, this is a picture from Sinaloa, which is grain bowl of Mexico, for example, and farmers tend to use large quantities of nitrogen. For example, in this case, you can see on the left, on my left side of the screen, the farmers applied 240 units of nitrogen per hectare, whereas our sensor-based recommendation was only 150 kilograms per hectare. And as a matter of fact, the crop looks very similar, and yields are also similar. Now, there are several questions. The efficiency of applied fertilizer and how much nitrogen to be applied basally. I mean, in some countries, for example, Europe, this is the question whether we should use nitrogen as a basal or not. And then, applying large doses of fertilizer can really affect the plant microbe relationship, and therefore the recovery of applied fertilizers can be another point of consideration. Now, one thing that I realized that not given enough attention in this part of world, which is soil compaction. And repeated tillage operations can cause soil to compact, and this reduced porosity and poor soil aggregation, aeration can cause not only water shortage and cause runoff, but also increase denitrification losses of nitrogen and reduce uptake of nutrient, for example, potassium, magnesium, and calcium. And therefore, if we do not give attention to the soil health, particularly on physical conditions of soil, probably we have to keep increasing our nutrient uses. Now, It is also known that the soil health is also linked to the animal health and human health. And this was realized as early as 1940s, wherein a scientist called William Albrecht realized that humans and animals provide a biochemical photograph of the soil on which they grow, which means if the soil is deficient in one nutrient, it's very likely that the population on that geographical point would have zinc deficiency or that nutrient deficiency. And this has been very well documented through different publications. Now, another challenge that we realized that in this whole game of commercial agriculture, monocropping is also one of the element that needs, some kind of concern. And what we have realized that in areas where same crop or same set of crops is grown over long period of time, for example, in this case, as you see, this is Mehikali Valley, where farmers tend to use the wheat as monocrop, one crop per year over many, many years or decades, rather, I would say, and they have all kind of problems. They have soil-borne fungus, the fusarium in wheat, which is can kill the whole plant, or resistant biotypes of Phaleris minor or volunteer plants, and so on. So, there are serious concern on monocropping. I mean, you might be aware of the fact that about 90% of agricultural land across the globe is cultivated by same crop. I mean, there are 6 crops that cover 90% of land, which is rice, wheat, maize, soybean, sugarcane, and cotton. So these 6 crops are repeatedly being used in monocropping system across the globe, and that is also point of concern. And therefore, we have to find a way of diversifying those production systems in order to develop a sustainable production system. On the other hand, the recent study from Eat Lancet report shows that unhealthy and unsustainable produced food and ecosystem, which means business as usual cannot go. We need to eat less, meat, more fruits, more vegetables, more legumes, less carb, less sugar, less salt. And therefore, now we are saying this, that the soil health and our production system should be linked to one health, and therefore our effort should be towards health and food safety, not only limited to food security or sustainability, but health of individuals is also a matter of concern when it comes to national security. Now, what we have done, I mean, we have been working on, sustainable production systems, and our target was always aimed at increasing yield quality, soil health, resource use efficiency, resilience, diversity, and sustainability, while reducing the risks, soil erosion, environmental damages, and climate change effects and stresses. As you can see in this particular picture, this is a long-term trial that we established in 2006. It's still running in Pusa, Samastipur. On the left is the maize grown with a conventional tillage system. On my right, is the maize grown on zero-till production system, on conservation agriculture-based production system. No tillage, residue retention, and you can see the health of crop and yields are in over years as soon as we dramatically reduce tillage, retain crop residue, and adopt diversification. And therefore, we developed long-term sustainable intensification and climate resilient production systems, wherein these three elements of reducing tillage, retaining crop residues, and adopting diversification was considered. This is the picture from Bisa, Jabalpur, where I was scientific lead for quite a time. We realized that you can harvest rice and plant any crop, wheat or maize or whatever, without tillage, and you can still keep on improving. Now, coming back to the experiment on Pusa, what we have realized over years, it's quite 2 decades, and in 2 decades we have realized that yields keep on going up while the cost of production going down, and you can see the change in the soil structure in this picture. On the left is conventionally grown rice. On the right is rice and wheat grown on conservation agriculture-based production system. So this is a dry year, and we are sitting in the same field. On the left is the conventional. On the right, it is the direct-seeded rice. The crop shows some degree of resilience and better growth. Now, the same case we realized in the Altiplanos or the highlands of Mexico, wherein this is the data of 28, 30 years of average data of long-term trial that shows that if we retain crop residues, we can, not only increase crop yield, but we can increase sustainability. As you can see, in the poor years without residue, the corn yield was 5.6 ton, and in good years was 5.6 tons, and in dry years it was 3.6 tons. But when we keep residues in good years, the yield was 7.8 tons, and in the dry years, the yield was 7.4 tons, and this is average of 28. This is fed production system. This is semi-arid environment, approximately 560 millimeters of rain and 2,200 meters above sea level. We have also got similar results while working in the West Asia. This is an example from Syria, and we have realized that, no matter what crop or what variety, cumin, wheat, grass pea, lentils, chickpea, wedges, or whatever crop you grow, you always get some, boost in yield while adopting conservation agriculture-based production system. This is an example of farmers' participatory program on large-scale adoption of conservation agriculture-based production system. And we looked into it, why this is happening, while using different set of genotypes, and we realized that it is the water. I mean, I have to admit here that this is an area where we get around 250 to 350 millimeters of rain, though the soils are pretty heavy, about 60% clay. Also, we have realized that by reducing tillage, we can reduce weeds, and even by adopting, good rotations. For example, in this case, this is state of Zacatecas in Mexico again, and there is a weed called Iragrostis mexicana. On my left in the screen is the triticale, where we have about 1,200 plants of Iragrostis mexicana. On the right is sunflower, which is without a single weed. And so just by shifting a crop from triticale to sunflower, or could be mustard or any other such crop, we can dramatically reduce a serious weed problem. We have also tried different cover crop mixtures to resolve several soil-borne problems, soil-borne fungi, the complex weed flora, compaction, and it is based on not using the same one species, but a number of species. And our observations in experimental plots as well as at large farmer participatory trial. Here you can see a number of crops. There is amaranthus, there is radishes, there is canola, there is maize, there is sunflower. And the idea is to have different canopy of crop. So completely, cut the solar radiation, and we put nitrogen into the soil. We increase the soil biodiversity, and we have more predators and parasites, and therefore it's a kind of ecological intensification rather than monocropping, and thereby increasing the water use, reducing compaction, and so on. And therefore we believe that this is time wherein we have to give equal emphasis not only on good agronomy, but also on natural resource management. I always, give these statements to the farmers and the extension workers that the sun should not see the soil, and soil should not see the sun. So the soil should be always covered with some kind of crop residue or a living, cover crop. Now, why I am saying this is mainly because of the bare soil can be, twice hotter than covered soil, and in a bare soil, the water, can evaporate very fast. The organic matter can get oxidized, and the biological activity can come to almost zero, or very low. And therefore, we believe that drought is always not because of the absence of rain, sometimes because of poor management, the soil which is not having enough porosity and hydraulic conductivity or the capacity to store soil water will show the symptoms of drought first. And similarly, the nutrient deficiencies is not only because of lack of fertilizers, but also because of poor management. Thank you very much. If there is a question, I would like to respond. Thank you. Any question?
Thank you very much, sir, for your presentation. I'm Dr. Sunil, working in Krishi Vigyana Kendra, Kaneri, Kolhapur, Maharashtra. Sir, from your point of view, what should be the time frame for adopting all these type of practices that are majorly contributing to the regenerative agriculture and this sustainable agriculture? How much farmers can adopt until 2047?
Well, I went to Madhya Pradesh, and I had a big dream of serving Maharashtra. And what I have seen in Maharashtra, that the fields are very clean. People love cleanliness in their field. Not a blade of residue you will see in the field. And this is, very sad. Now, coming to your question, Sunil, I would say that there is a saying, walk before you run, So if you want to have this, we call it regenerative agriculture or whatever the name you give, we can have a small step. For example, having some kind of mulch, having some kind of cover crop, having, a good rotation, first step, baby step, and then slowly moving forward. Now, why I am saying this, that if you are not fully trained on these practices, you also need to have, we also need to have confidence on what we are going to do. Therefore, I was fully equipped, playing with it. But if you have not played, have not played this, and if you don't have confidence, I would suggest that it starts with baby steps, and your larger objective should be, sustainability, increasing water use efficiency, and so on. So start from somewhere. And if you need, you can connect me. I mean, you take my number from Sudhanshu, and we can discuss, and we can develop a specific plan for your location. I will be very happy to help. Thank you. Sorry for long.
No issues, sir. That's your experience that you are saying, and that is, I think, I will share with all the participants. Your experiences are always invaluable, and if we can follow some of the 10% of those experience also, we will, our farmers will be benefited more, sir.
Yeah. Another thing that I wanted to do in Central Plateau region, that all the planters in Central Plateau region lack depth control weed. So the planting of different crop is done by a seed drill or a planter without having a mechanism to hold the machine at particular depth. So that is also something, could be the first step towards that. So a right depth of planting can be, very, very effective in enhancing productivity. Thank you.
Shivani ma'am. Shivani ma'am.
Thank you, Sudhanshu ji.
Thank you so much. Thank you. Thanks a lot for your blessing, sir. I think Shivani ma'am is having some network issue. Okay, thank you so much, sir. I must come to meet you, sir, to get your blessing in person also. Thank you so much, sir. Thanks a lot.
You're welcome. Thank you
Next,
so much.
do we have Dr. Manjunath, sir? Thank you, sir. Thank you so much. Sir, your PPT is ready. You can start, sir.
Please share. I'm audible, right?
Yes, you are audible. Sir, you may start.
Yeah, good evening to all. I welcome you for my lecture on melon breeding for biotic stress tolerance and Indian perspective. Presently, what is the scenario existing in the breeding status for melons, especially at IIH, Indian Institute of Horticulture Research, and I welcome you all for this lecture for the National Conference on Agriculture, Innovation, Sustainability and Leadership for Future India 2026. Please, yeah. If you see the importance of muskmelon in India, we've grown in 0.5 million hectares in terms of 54,000 hectares, and the production value is 12 lakh tons. If you see the turnover, market rate in India is 1,230 crores. Domestic trade has been happened annually, and the seed rate, it requires around 27 tons per annum. Every year it requires 27 tons. If you see the seed rate, nearly 27 crores business is happening in India in the domestic level. The muskmelon grown throughout the year is limited. which may be available in summer season, which are grown in the rabi season due to the climatic preferences. Whereas if you grow, it's very difficult to grow in rainy season because of more disease prevalences and production practices, and we are working for that. Again, if you want to breed any disease resistant program, you should have a germplasm plan. At IHR, we are maintaining 238 breeding line germplasm, which are prominent for disease resistance. We can see the photographs of the field in the lower left side. We can see the prominent disease resistance line for WMU, and it will be presenting in the later slides also. Next, please. The germplasm varied with characters with a different range of the food size, with 180 grams to 2 kilo, and PSS range from 2 degree Brix to 8.2 degree Brix. This lot of variability has been there in our germplasm. These could be used for exploitation of breeding values, breeding traits in the melon breeding program. Next, please. So we can have a better breeding programs in the masculine breeding. And if you see the segments, there are several segments available in the market. Canary melons, which are yellow ring and white flag with high TSS, Dahlia types are more prevalent. Japan and honeydew melons in China, Cherentia types in US markets, and cantaloupes in US markets, and Kajari, especially in North India, and Maduras from South India. These are all the segments, major segments available in India as well as the world, and we are focusing for export. So we are looking for Dahlia, Cherentia type, and cantaloupes to focus on export orientation for Japan as well as US. Next, please. Next, please. Yeah. If you see the new advanced lines we have bred at AHR in the cantaloupes types in the muskmelon, there are 3 advanced lines have been identified, and one variety has been released in the last year, and which is notified by SBRC, and that will be presented in later stage. Apart from that, these 3 lines are performing better with respect to TSS. TSS is a very important trait for the masculine breeding program, especially sweetness, and these are all aromatic types. They can be used next for advanced lines for release of the varieties. Next, please. And these are all reticulatous types in Cherentia types. Another segment we have in the canary melons. Canary melons are yellow ring white flesh types, and recently we could able to identify white instead of white flesh, yellow ring with green flesh type, which are very unique genotype. You can see the IHR 825-2. We could able to identify the bred these lines also, and these will be advanced breeding lines performing better on the replicated trials and multi-location. We have given for multi-location trials also. These may be very good material to advance in the next pipeline to SDRCR's acre trials available to release notifying the next level. Next slide, please. And another segment is Oriental picnic melon, which are salad type. Especially we can use for cooking purpose, as well as some people use for salad at the immature stages. And we have several lines, and these are the promising lines we could able to establish in the replicated trials, and we could able to identify better lines among the best lines. These 2 lines are IHR 617-4 and IHR 618-2, found to be yield performance than the other lines. Even though all the lines are performing better, I will show you the next slide, please. The image characteristics of these lines. Next slide, please. These are all the characteristic features of the best performing lines, and out of these, the yield performance of IHR 617 and dashboard is best because higher yield with the low cavity, as well as the white flesh with yellow color. It can be used for normally as a cooking purpose. Next slide, please. Especially the core aspect of this topic, breeding for biotic stressors. Among biotic stressors, there are three major diseases we can see. One in case of muscular, downy mildew, fusarium wilt, as well as gummy wilt. These three major diseases are mainly devastating mushroom cultivation across India as well as world. So we have a breeding program for downy mildew resistance in IHR Bangalore, and we evaluated around 260 lines. What I have said earlier in the slide development program, and among that we have shortlisted 17 lines. Again, we have evaluated these 17 lines in the replicated trial, and out of these 17 lines, we could able to find the 6 best lines. Out of 6 best lines, 1 line is performing highly resistant for downy mildew, that is IHR 796-3. The next slide. You can see the field view of this performance. Next slide, please. This is the downy mildew screening program. This is because downy mildew is an obligate parasite. We cannot do screening in the lab condition. It can be done in the field condition. This is the one line in the lower side. It clearly indicates the downy mildew resistant line for muscular. Yeah. Again, the screening has been repeated to confirm the disease resistance for downy mildew in the next season, next year as well. And the same line has found to be best for downy mildew resistance. Next slide, please. You can see the disease as a comparison of the line. At 60 days, a clear-cut disease difference has been shown in the picture. The disease resistance line versus susceptible in the field level. So we could able to find the best line for disease resistance is IHR 818-2 is found to be best lines compared to the other lines. Yeah. And this line will be useful for advancing for next release of the program for disease resistance in the muscle. Next slide, please. Another major disease is fusarium wilt. In the fusarium wilt, there are several races. Fusarium wilt, axis forum, Melanis race 1, race 2, and race 3. Among the three races, fusarium axis forum, Melanis race 2 is the most prevalent race in India, and the race is devastating more in case of muskmelon cultivation. So we have a program for breeding for muskmelon resistance to fusarium wilt, and we have a screen all the different levels, and we come up with 6 best lines, which we have validated these lines with marker, especially marker with AS PCR, that is allele specific PCR marker, that is 2-3-3, and this marker, next slide please. We confirm the resistance with these 6 lines with marker. Already these marker has reported, and those marker has been validated in our program, and we confirm the transferability of the disease resistant marker in our lines as well. So these 6 lines will be very prominent for disease resistant fusarium axis species Melanis race 2, especially these 6 things. Yeah, next slide please. Another major disease is gummy stem blight. Gummy stem blight is among all the cucurbits, it's a more devastating disease past 3-4 years. Again, compared to other cucurbits like watermelon, bottle gourd, gourd, again, the muskmelon is highly susceptible for gummy stem blight. Again, gummy stem blight is caused by 3 major species: Stegnosporosis citrullis, Stegnosporosis caricae, and Stegnosporosis cucurbitacearum. Among 3, the Stegnosporosis cucurbitacearum is the most devastating species in case of muskmelon, and this is the program we have evaluated screening for downy mildew resistance, especially the gummy stem blight resistance, and we could able to identify one line, that is, which is next slide please, which is resistant to gummy stem blight, that is IHR OPM 6. we could able to identify one line which are highly resistant for conventional blade, and we are working for in progress these resistant lines to the edible segments, especially in muskmelon background. We are working on this transfer of the gene resistant for the next building program to identify the gene action and markers. We are working on this aspect as well. And next slide. Yeah, again, the resistant lines has been multiplied, and we could able to get the seed, and we have multiplied it and sufficient seeds are kept. And if anybody want to work on these aspects, we can send a MTA and we can share the seeds to have a collaborative work in the future as well. Next slide, please. And again, another program, we have a diversification of melons for especially quality traits as well as the students. We have made different melon types with muskmelon, and we have developed different F1 backgrounds, and we are working with segregating populations with oriental melon, with processes with muskmelon, and long melon process with this thing. And next slide, please. Especially, we are working with diversified classes of the melon breeding program. These are all the one of the important aspects for breeding program to breed a new elite breeding lines to progress or to get desirable traits, to get any additional desirable disease resistance, especially the wild species having more disease resistance compared to adopted one, and we are trying to in progress those to cultivated. So we are advancing all the efforts for the next year. Next slide, please. And we have developed several backgrounds with different generations, and our MSc students are working on different populations, the cross between Finnish mellow and long melon varieties, Longicus with Finnish mellow cultivators, and the student is working on this aspect, and another student is working on different aspect with the Konoman background, with oriental technique. For the introduction of different aspects like disease resistance for the donor mildew as well as disease resistance for the fungal stability as well. We are advancing these populations. Next slide, please. This is the diversity of the F2 populations we could got in the last season from the oriental melon background, Kokumis mellow, and Kokumis mellow variety. Next slide, please. And we have advanced, we have developed one variety that's selection 24, and we, by the intervarietal process made between NS910 and NS2. By advancing these intervarietal process, we developed F2 populations, and F2 populations were advanced for individual plant selection. And we identified the selection 22 one line, and we named it as Artha Siri one variety. We named it as Artha Siri, and it has been recommended in the institute, and now it is recommended for the state of Karnataka. Next slide, please. And this is the selection 24, the key characters. It is performing well across the state as well as many people we have licensed to companies as well, and it's a very good variety, open pollinated variety. Farmers can produce the fruit as well as they can multiply the seed their own by maintaining the isolation distance. And 90 days between 75 kilos, 90 days, the rain time and rain to be able to complete the crop. And this is the orange plus very aromatic segment, segment. And this is very good performing the recently, we have sold around 181 kgs of seed in the year 23, and we have generated around 296,000 fish from the musking line in the year 2023. And they are selling 180 kgs of the seed. Next slide, please. And in the year 2024, we sold around again 50 kgs, and we generated around 5 lakh 4,000 rupees nearly, and we could able to sold to 500, nearly 500 farmers are got the seeds in the last 2 years. And it is picking up nowadays. The variety is picking up from the farmers based on the spread, and it may reach very well by this year also. It's like this. I'm ending my seminar. If anybody having any queries, any doubt regarding these aspects, we can have a discussion. And I thank you for organizing committee, Subhanshu ji, and everyone for giving this opportunity to present our work in front of the audience. If you have any doubt, if you have any request for material, we can send them here. We can have a sharing program, collaborative research program to be balanced for better India. Thank you. Anybody have any queries, discussions? We can have discussions. You can unmute.
Good evening. I'm Pallavi Deshpande, founder of Pallavi's Management, and I feel immensely honored to welcome you to the day 2 of National Conference on Agriculture, Innovation, Sustainability, and Leadership for Future India. Today we also have NGO Day, so we are celebrating the spirit of service and social responsibility that you are really taking and giving us all the tips for sustainable development. It is a privilege from now on to host such a brilliant mind. Right now, I'm going to host your scientific clarity that you have given just now and your research driven perspective. It really added a great academic strength to this session. The depth of your horticulture knowledge was very impressive. When we saw the muskmelon, the people around us, the family members said that we definitely need to listen. And even the children joined the session and they were just very much interested.
Yes.
So very happy that you have given a wonderful and in a very simple language what future India can be with your knowledge, with your guidance and your visionary thoughts. So if there is any questions, we can let know Manjunath Gowda sir. And thank you for being on such a wonderful platform.
Yeah. Thank you, madam. Thank you for opportunity as well.
Shivani ma'am, are you there?
Pallavi, you can continue. Now onward, Pallavi ma'am will continue. Ma'am, you are on mute. Pallavi ma'am, you are on mute.
Do we have Dr. Vishaka Singh, Krishi Vignan Kendra Ranchi? We would like to invite Dr. Vishaka Singh.
Sir, ma'am is not able today as there is Krishi Mela.
So,
because of that.
Do we have Dr. Priya Yadav, Assistant Professor, Dr. B.R. Ambedkar University, Agra? Can we continue with the oral presentation, Sudhanshu sir?
Yes, please.
Yes, ma'am,
Please.
you can.
Okay, great. So now we have Dr. Tarun Kumar Das, Subject Matter Specialist, ICAR KVK, West Garo Hills, Meghalaya. Is he available?
Sorry to
for the-
disturb. I think my lecture was left there and nobody calls. I'm Dr. Sunil.
Dr. Sunil.
Yes. Sorry, sir.
We have already invited.
Yes.
Sir,
So
you
now
can,
we
sir.
invite Dr. Sunil Kumar, subject matter specialist, Sri Siddhagiri Krishi Vignan Kendra, Kaneri, Kolhapur, Maharashtra. And today being a Maharashtra language day, Marathi language day, we really
Yes.
look up to you, sir, for your speech. Please go ahead, sir.
Now it is visible.
Yes, it is visible. Natural
Okay.
farming for agriculture sustainability.
Yes. Okay. Thank you. Thank you to the organizers for 360 Research Foundation, and we have already conducted some two to three activity along with this organization, and they are doing well in this. So they have invited me for this special topic for delivering a lecture on this particular important now ongoing schemes and ongoing programs are also more immediately focusing on natural farming or the sustainable agriculture. How can we how can we benefit for our farmers? So I'm Dr. Sunil. I'm working as a subject matter specialist. Subject is agricultural extension in Krishi Vigyan Kendra, Kaneri, Kolhapur, Maharashtra. We are already looking for the Indian agriculture scenario where the land of farmers are day by day they are they are being you can see the degradation of the soil of that particular area, other particular states of India. The land holding of the farmers are majorly shifting to the a small and marginal farmers category, having less than an hectare, 1 and 2 hectare of the area. So this produces an alarming situation that how can farmers sustain their farming income from these 1 or 2 acres of land? And in this scenario also, the cost of inputs are also increasing. So this has provided always there are scenes that any of the challenges is also providing some type of opportunity for us. So we also call as the normal proverb that necessity is the mother of invention. So here we can see this problem as an opportunity for our farmers to increase their production in case of having lesser area, having lesser than 1 or 2 acres of land. So the type of initiative that has been shifted nearly in this 10 years, mainly shifted towards the natural farming or the organic farming initiatives. So in India, there are different types of natural farming or the organic farming that you can call it. They are being disseminated among the farmers, and there are a number of farmers who are doing this type of farming. Somewhere it is called as a Vedic Krishi, somewhere called this as a Panchang Kheti. Some now particular verb is there for the natural farming, that you have to produce all the inputs at your farm and you have to get the aid from that only. Permaculture is a new concept. It is not a new, but it has been generalized as a new, and that can be sustainable for our farmers. Zero budget natural farming has been produced and famous by Padma Shri Subhash Palekar, who is the originator of this particular type of natural farming practices. Then homo farming, yogi kheti, straw farming. These are the types of organic farming, you can say, or the farming which can sustain the farmers without using the chemicals. So if you can see the data of this particular organic initiatives, from the data of this particular PGC scheme we have taken for the year of 2024, and you can see that there are a number of schemes has been run to sustain the farmers in case of organic farming or the natural farming. There are farmers. There are certainly the numbers are increasing in the state in the different states of our country, and majorly they have been growing past by the 20 lakhs of the farmers, having the area of more than 12 lakh hectare area, and certified by different types of initiatives like PGS is there, NPOP is there, and some state initiatives is also there. So by this number, we can see this is gaining the importance in the present scenario, and having more than around 10 lakh of hectare area and covering more than 17 states, and having more than 28 lakh farmers, in particular this type of organic or the sustainable agriculture manner. It is not a joke, but the farmers are accepting this type of farming system. If you are looking to the development of this particular world of this natural farming, other farming where the chemical inputs has not been allowed, they have been replicated, or they have been shifted by the other local inputs. So before 1947, there was ancient farming that we called as our Vedic farming and other things that was there. The major shift was happened during the Green Revolution era, where the need was there also, because we were suffering from our yield production in area, and at that time also that M.S. Swaminathan sir has brought this term of our Green Revolution by producing or by introducing the types of high yielding variety seeds and chemical fertilizer. That was the need of that particular age. And after that, there are some other initiatives were also there, like for creating awareness and initial movement for organic farming, and other things was done. And in the recent year, you can see also like some of the other programs were also being developed and implemented to the farmers, with like Paramparagat Krishi Vikas Yojana, Soil Health Card Scheme, now this particular term of ZVNF, and sustaining the farmers in the different types of initiatives, also like having the scheme of this particular National Mission on Sustainable Agriculture. And now at present also, in 2024-25 also, government has given this particular scheme of National Mission on Natural Farming, which are being covering all sorts of natural farming practices, and providing the landholding or the handholding support to the farmers also. So in the jurisdiction area of our major component under this natural farming status also, you can see the major component or the major pillars are there for Bijamrut, Jivamrut, mulching, WAPSA, and the plant protections measure. So different types of benefits also there, because it improves your soil health, supported and it reduces the environmental impact, supporting your biodiversity, having more numbers of crops, and it can reduce the production cost. That is the major factor for the farmer, and to sustain them, they can use that product for the market, and they can get the extra income with this. How we can achieve the natural farming practice, or how we can start it, because we have to adopt the diversified cropping system based agriculture, where the mixed cropping and intercropping will be the key, along with the crop rotation practices. And we have to recycle the naturally available nutrient in the field, maybe through the on-farm composting methods, or maybe the types of green manuring, or the aero green concept. And the recycling on the farm generated biomass can be done with the help of mulching practices and the biomass incorporations. For the locally available plant protection measure are the plant health that should be focused through different types of microbial inoculations that may be called as a Jivamrut, Vijamrut, and these all types of indigenous microorganism can be used. And these natural pesticide and fertilizer and natural pesticide, it can be used Dashpanir, Nimastra, Brahmastra, and other practices is also there, integrating the animal. But the animal can be beneficial in terms of providing the raw material for the natural farming, where all this dung and urine are the basic resources for the farmers. So in case of this, because we can sustain our indigenous breeds of cow that is having the central concept of this natural farming. For the innovative practices, we can go for the local knowledge or the ITK that the farmers are already following in their area, continuous observation, and the experimentation can be done for the different crop and in the different season also. So these are the basic. This will be the basic parameters or the things that has to be done in the whenever we are starting for the natural farming. We have developed one of the natural farming model majorly for 1 acre, because we have taken 1 acre as a land of basic unit here, and it is called as a Lakpati model. Why it is a Lakpati? Because the farmers can save, after expending all these expenses, he can save around more than 2.5 lakhs in a year. Otherwise, if he is running in all this crop and one of the seasonal crops, he cannot maintain this diversity, and he cannot gain that much of remuneration. So in this model, one desi cow will be used for the dung and the urine, and here the concept is to diversify the crop. As much as you can diversify, you can get the most of the income. So you can see here the types of cereal crops like then the oilseed, fruit, vegetable, wine, and all these crops are there. Majorly, it is integrated with the vegetable, cereals, pulses, oilseed, and all these crops, and it is having some of the combination is also there. Parameters is also there, so that can be used in the farming. So here the crop is there, like cereal and pulses, root crop, tuber crop, and other vegetable, leafy vegetables is also there for our. And season-wise, there are major crop combination under this natural farming will be the in case of vegetable, it can be the tomato, beans, and cucumber for the Kharif season, and for the Rabi season, cauliflower and pea and other crops can be stayed according to the needs and according to the climatic condition. For the vegetable cereal also there are some of the specific Kharif season and Rabi season combinations of crops has been produced, and some of the vegetable and pulses for the cereal and pulses also, and vegetable and oil seeds also. So these are some of the combinations for your different season in Kharif and Rabi season. For having natural farming input preparation unit at our KVK also, we are having in Ghanjiva Amrut input unit, where we are producing around 5 quintal per hour for this Ghanjiva Amrut. You can see on the last photo, beside to this photo, there are bags is also there. And some of the other input center is also there, where all this natural farming input has been shown, and that has been given to the farmers for multiplications also. So the native composting, ring vermicomposting, and vertical step farming. These are some of the innovative and low cost technology that farmers can use in their farming farm. For the crop capacity and the natural farming, we have a different crop all the seasonal crops and along with the millet crop, and we are only using the Ghanjiva Amrut, biogas mulching, and Dashpandian, and other than the Nimastra. You can see all the crops, and you can see the diversity of crop that we have maintained in our field. Like millet crop blocks is there, cereal blocks, pulses, oilseed, green manure, leaf vegetable, nutrition block. Then the beans and fruit vegetable, exotics vegetable, also root vegetable, and all these in open, and all the natural input sources, and we are taking always the training and courses for the natural farming. We are having one of the center for this state initiative under natural farming, that is Punjab Vishnu Shandhi Shakti Mission, and that and we are having a training center here, and we have last year we have trained around 3,000 farmers under this, covering more than eight districts. So according to my works, the strategies for the strengthening natural farming practices can be here. First should be the demonstration plot, because because we are following in the extension is seeing is the believing. So without seeing, you can't believe. So whenever there should be the establishment of cluster-based model farm, maybe one for 5 villages, that majorly showing the ZBNA practices, polyculture, and other practices under this conduct and majorly conducting the seasonal field days. So that farmers can compare those with natural farming and the conventional farming, and producing more of the low cost techniques. So second will be the capacity building and training for the farmers. Maybe 3-day or 4-day activities can be done. Market linkages can be done through the natural farming producer groups. Maybe and different types of platforms can be used. Organic Mandi, Jaivik Kheti portal that can be used. And for the digital tools also, for advisory, we can use AI chatbot, that is Kishan Mitra for pest disease also, and having community support maybe through the different types of farmers field school for the peer learning courses. For awareness creation, we can go for institutional partnership, and some of the grassroots campaign can be done. And for the participatory research and innovation, we can go for some of the on-farm trials, and maybe for the women cooperative, for seeing the participation of, we can go for cooperative ambassadors. We can use for some of the IoT and remote sensing technology also. Maybe it can be linked to the microfinancing. So the farmers are there that we have developed as a natural farming, and they are doing excellent work in their area, and having adopted all this product. This particular farmer that we call as Adinath Kinikar, he has developed one of half-acre model of mixed horticulture block, that you can see the types of fruits crop that he is growing, and he is earning more than 2.5 lakhs from this half-acre of land only. And his success story was also documented by Niti Aayog on natural farming. Some other farmers is Tanaji Mari, who has developed this, who has majorly growing sugarcane, because Kolhapur is having predominantly crop of sugarcane, and he has developed he has shown his capability from growing crops to the processing of that particular produce also. Similarly, for Surendra Jainath Patil also, he has opened one of the center also for selling his produce. Appa Sahib Patil is a same organic horticulture based integrated farming system under the drip irrigations. So there will be this different type of strategy for one or two there, majorly for the starting of these natural farming practices. Mass awareness and campaigns can be done, and the different types of conservation and rearing of indigenous wheat can also be done, following the different type of extension methodologies for populating that particular products by fertilizer, farm mechanization, and strengthening our market and certification structure. For the medium-term strategy, the education and research program supporting service development things can be done, and development of biobank that we call as a BRC, that bioresource bank, that the government is already implemented under these national mission on natural farming, and focus on microorganism research development in this area, and strengthening this policy guidelines. And for the long time strategy, we can majorly focusing on long-term research and development, maybe through different types of research and investment also. And it should be linked to the innovation and customization of those particular local available technology, advancing to the farm mechanization. So all this can be a major area for the natural farming with this particular type of strategies. Thank you very much. If you have any question.
Thank you, Dr. Sunil Kumar, sir. Your field-based insights really connected science directly with farmers and real-world sustainability. And you reminded us that innovation really begins at the grassroots. Thank you for such an energizing platform with the practical wisdom that you have given to all of us who are present here. If there are any questions, we would definitely welcome them so that Sir is over here and he definitely can guide us further.
If any question, that will be good. If not, we can give chance to the other farmer because it is already 8:15.
So, thank you once again for enlightening with such beautiful knowledge. And now I would like to inform that now we are entering in a next technical session. And chief guest today, let us all welcome and extend a grand and a glorious welcome to our esteemed chief guest, Dr. Rathod Lal Singh ji. He is the associate dean in charge, a leader of vision and precision. Sir, we really want to welcome you with pride and gratitude. Your presence will definitely bring inspiration to all of us. So we welcome Dr. Rathod Lal Singh.
Thank you, madam. Hello.
Welcome, sir. Welcome.
Can I start now?
Yes, you may proceed. Thank you so much. And you may proceed.
Okay, right. So, myself, Dr. Rathod Lal Singh, entomology assistant professor at School of Agriculture, SR University. So, welcome you all to the 6th National Conference on Agriculture Innovation, Sustainability, Leadership for Future India. Honorable dignitaries, esteemed scientists and academicians, policymaker and industry representatives, progressive farmers, dear students and friends. I am extremely happy and honored to be part of the 6th National Conference on Agricultural Innovation, Sustainability and Leadership for Future India. I sincerely thank the organizer for giving me this opportunity to address this august gathering as a chief guest. See the importance of the theme. It is a very relevant and timely theme. Today, Indian agriculture is standing at a very critical stage. One side, we are facing climate change, soil degradation, water scarcity, increasing cost of cultivation. On the other side, we are expected to ensure food security, nutritional security, livelihood security for more than 140 crores people. In this situation, the theme of this conference is highly relevant and timely. Innovation gives solution, sustainability ensures continuity, and leadership ensures implementation. Without leadership, even the best innovation cannot reach the farmer. See about innovation. Innovation in agriculture should not remain only in laboratories, research paper, and conferences. It must reach the farmer field. Today, agricultural innovation includes digital and precise agriculture, artificial intelligence, and data-based decision support, climate resilient crop varieties. However, our real success lies not only in the innovation but in the adoption. Innovation is meaningful the when improve the farmer incomes and reduces the risk. Next, come to the next word, that is the sustainability. Sustainability is our responsibility. Sustainability is no longer optional, it is a necessity for survival. We must give priority to restoration of the soil health, efficient use of water resources, integrated nutrient and pest management, scientifically validated natural and organic farming, and conservation of biodiversity. As a teacher and scientist, we must promote science-based sustainability, not blind practices. We are not owner of natural resources, we are the custodian for the future generation. The next word in the theme is leadership. Leadership is the most important requirement in Indian agriculture today. Leadership is needed at three levels: at academic level, at scientific level, at student level. At academic level, universities must move beyond classroom and focus on skill-based education, industry and farmer linkage, and experience learning and entrepreneurship. At scientific level, researcher must focus on problem-oriented research and interdisciplinary solution. At student level, student must become job creator, not only job seeker, and they must be ethical professional with rural commitment. Technology alone cannot transfer agriculture, but the leadership can transfer it. So the role of SR University in this regard. At SR University, we strongly believe in outcome-based and industry-oriented education, research with social relevance, innovation, incubation, and entrepreneurship, strong extension and farmer engagement. I am proud to say that SR University secured the 91st rank in the engineering category in NIRF 2025, improving from 98th rank in 2024. This is the fourth consecutive year the university has been ranked among the top 100 engineering institutions in India. At the SR University, the School of Agriculture has a strong academic base with 480 undergraduate students, 30 postgraduate students, and 50 PhD students. Our aims to produce competent, confident, socially responsible agricultural graduate who can lead Indian agriculture. And our university School of Agriculture is going to be accredited by ICR, and ICR team has recently visited our college, and we are going to get ICR accreditation very soon. And the final message to the student and young researcher: choose a research problem based on farmer realities, publish with purpose, not for promotion, respect farmer knowledge and experience, think like solution provider. India does not need more degree holder. India needs problem solvers. I congratulate the organizer for bringing together scientists, academician, policymaker, industry expert, farmer, and student on a common platform. I am confident that the deliberation in this conference will generate meaningful idea, strong collaboration, and practical solution for the future of Indian agriculture. Let us move forward with innovation in our thinking, sustainability in our practice, leadership in our action. Thank you all. Jai Jawan, Jai Kishan, and Jai Vigyan.
Thank you, Dr. Rathod Lal Singh. Sir, really powerfully you have highlighted how agriculture, sustainability, and leadership together we form the backbone of future India, especially under the visionary academic environment of SR University. You were telling that there were 50 PhD students and they are being contributed not only to society but to the nation. Amazing. We need more guidance from all of you. You have really connected innovation with responsibility, reminding us that the true leadership in agriculture means nurturing both land and nation. Thank you for your inspiring word, and they have really strengthened the commitment. Thank you very much. If anyone has questions, we will take it. Otherwise, we'll move to the next session.
Okay, madam. Thank you.
Dear participants, if anyone is having any question, you can ask. Please feel free to ask question.
Well, thank you very much, sir, once again. And can we move to the oral presentation, Sudhanshu, sir?
Okay, thank you, madam. We can move.
Yes, ma'am, we can.
Great. So now we have oral presentation, and let me remind each one of you who are presenting over here that 5 minutes will be given and 2 minutes for question answers in case anybody has it. And we are looking forward for a great presentation from all of you. Let's welcome if we have Dr. Tarun Kumar Das, Subject Matter Specialist, ICAR, KVK, West Garo Hills, Meghalaya. Do we have Dr. Tarun Kumar Das?
Yes, madam.
Welcome, sir. You are giving a presentation on indigenous community-based fishery approach practice for biodiversity and natural resource management by Garo tribal farmers. So we welcome you, sir. Do enlighten us, and if you have any PPTs, please share it.
Is it visible, madam?
Yes, yes, it is visible. You can
Am
go
I
ahead.
audible?
Yes, yes, very well, sir.
Okay, good morning. Good evening, everyone. Myself, Dr. Tarun Kumar Das. So my topic is indigenous community-based fishery approach, practice for biodiversity and natural resource management by the Garo tribal farmers in Meghalaya. If you talk about the Meghalaya, so Meghalaya is known for the adobe of clouds. It's a treasure for the natural resources and biodiversity. Here, the states cover 75% of the states cover is forest. And the state is boosted with a reach of biodiversity, wildlife, and exceptional area of flora and fauna, including 300 species of orchids and many more. And in the Meghalaya, so there are three regions which is known by like Garo Hills, Jaintia Hills, and Khasi Hills. So my study area is in Garo Hills. So in Garo Hills, so one of the major tribe is Garo. So one of the and they are very much fond of rearing livestock as well as agriculture as a part. And most of the areas in Garo Hills area, so though they are doing the agriculture, so there is the, I mean, like irrigation sources mostly the streams and rivers, maximum streams. The streams they are using for the, I mean, like drinking of water purposes also, and as well as irrigation purpose. And in that stream, so they are rearing they are having a lot of like local fishes which are mainly liked by the Garo peoples. The aquatic ecosystem are more often and protected by the local communities through the traditional conservation methods such as community management fish sanctuaries. The indigenous method, that is community-based fishery approach, help in sharing the environment for fishing and maintaining biodiversity conservation for natural resource management and ecosystem. Why this indigenous approach was practiced? So here the villagers believe that most of the streams they are, I mean, like peoples they are day by day they are using, and they are thinking that this stream needs rest for the multiplication of the local or indigenous fishes or other creatures like a snail and all. So they believe that. So because of the to increase this population, so this practice was practicing by that particular tribes, because day by day the number of the snails or the local fishes are getting extinct. And they also believe that these are the local names like Nakolthok, Ronda, Nagichak, Bengal. These are the local name of the fishes, indigenous fishes. Though I mean, like some of the fishes are not yet registered. So ICR they are still on the way of registering some of the local fishes in Garo Hills as well as in Meghalaya. So these are the local fishes are getting extinct. And how this approach works? This approach, how it works, to implement this approach, the villagers they select the particular streams which is flowing through the some of the villages. then 2-3 villages they will be selecting, and they will conduct, all the village members, they will be conducting the meetings regarding the making some resolution or conservation of the or implementation of this approach. All the villagers will select a committee members where it will be formed with a 10 to 15 members, that committee members, they will be making some rule and regulation to maintain that indigenous approach. The committee also they will assign or they will select some of the person to take care of that particular streams. They also decide the name of that approach. Whether sometimes what happened, I have given one name, that Salbalgari Nathok Reserve Committee. Nathok is locally named as a fish, so that sometimes they give the name of that approach as a related to the villages. Like this is also Salbalgari, like another you can see Rongramgiri. This is the name of the villages, where these villages they will be taking the main role of maintaining that approach. So slides is not moving. So coming to this rule regulation, so they will make some of the rule and regulations. So I'll be highlighting some of the points in the rule and regulation. No one is allowed to harvest that fishes or snails from that particular streams for the year of 5 years or more, that is said by the committee. And second point is, no one is allowed, if anyone found that he is practicing fishing or this and then he has to or she has to pay 50,000 as a penalty. No one is allowed to throw the plastic into the streams, because it will create a pollution to that particular streams or the creature, aquatic creature. Fishing using the hooks, fishing hooks or traditionally made tools are also not allowed. Villagers are allowed to harvest when the small channels coming out from the main streams or main like during the rainy season. So some of the streams came out during the rainy season, so they are allowed to harvest the fishes from that small channels, but not from the main channels. Every year the committee will inquire the status of the streams and the status of the fish population and all. The committee will maintain a register or open a bank account to maintain that approaches or the practices. After completion of the 4 and 5 years, the set by the committee, the villagers they will be the committee they will be deciding a particular date and timing for the harvesting. So in that particular date or time, all the villagers they will come and they will harvest the fishes. After harvesting the fishes, they will collect all the fishes in one places. After that, they will do? They will distribute according to the household. So suppose some family members are absent that during the time of harvesting, but they will be keeping the share of that fishes to that particular house also. Coming to the impact, if we will see the long-term impact of these approaches, it is a sustainable biodiversity conservation and improve the socio-ecological resilience in Garo Hills regions. And key elements here, this is the conservation of the native fishes, restoration of the aquatic ecosystem, improve the household livelihood security, and strengthening the traditional governance system. Here the key indicators or the evidences are increase the native fish population biodiversity and reduce the destructive fishing practices and improve the food security index and enhance the ecosystem stability. Coming to the outcomes in midterm results. So it's improved the management practices of aquatic resources through the indigenous governance. Here key elements is the community regulation of the fishing regions, protection of the breeding ground, reduce the over-exploitation on the streams or the fishes, increase the collective acting along the chain. And key indicators here is the observance of the closed fishing regions, reduce the conflict over the water resources, revival of customary laws, the traditional practices, and greater participation of the youth and the women under this approach. Coming to the outputs, that is immediate deliverable. So tangible community action and institutional mechanism. Here the village fisheries sanctuaries are established, traditional fishing norms are enforced, rotation of harvesting system, and knowledge transmission for elder to youth. Here the key indicators is number of the protected strengths of the streams, community meeting conducted, awareness programs, and adoption of the.
Interrupt,
Hello.
sir. So I think we have Mr. Suresh. Kindly put yourself
me.
on mute. We have Suresh over here. Thank you for unmuting. Thank you. Can continue, sir.
Yeah. Here you can see the emerging outputs. So it is a natural resource conservation practices traditionally followed by the Garo tribes since ancestral times. And this technology is not yet documented yet. So I have decided. I study still, I mean, like under the process, though I have covered to some extent. And so this technique also implements without disturbing the environment or the existing ecosystem. It has a several location and conserve the area become more tourist attraction. The tourism development also they are currently overseas and managing some of these areas. This practice is gaining a popularity and adopting many villagers in the different villages because it's related to nature. And coming to the constant of this approach, so limited financial resources for the community conservation activities, lack of the formal legal recognition of the customary fishery sanctuary, inadequate technical support and scientific inputs, weak documentation of indigenous technological system, limited access to the organized fish market, poor infrastructure, insufficient coordination between the traditional bodies and governance, limited training on sustainable fishery enhance the practices, seasonal water scarcity in the hilly streams or hilly areas, restricted institutional funding. Then coming to the challenges, so increasing the commercialization leading to the overexploitation and use of destructive fishing methods, climate variability affecting the rainfall and stream ecologically, habitat degradation due to the deforestation and land use changes, siltation and sediments deposit in the breeding grounds, decline of in the youth and migration reducing knowledge transfer, introduction of insensitive or exotic fish species nowadays, and rising the population of the pressure on aquatic resources and conflict between the traditional norms and modern regulatory framework, and illegal fishing during the breeding season should take place. Coming to the conclusions, however, the sustainable system practice faces a pressure for commercialization and climatic variability, habitat degradation, and weakening the traditional institute. Without the adequate institutional recognition or scientific support and youth engagement, the continuity of this indigenous practice may be in risk. Overall, if the Garo community-based fish system offers a replicable, low-cost, and ecological sound framework for the participatory natural resource management and strengthening the policy integration and documentation and adaptive co-management strategy to enhance its resilience and ensure long-term biodiversity conservation in the regions. So that's it for my presentation. Thank you. Hello.
Thank you so much, Dr. Tarun Kumar Das, sir. Brilliantly explain how the fishery approach practices by Garo tribal farmers really supports biodiversity conservation and conservation, sustainable natural resource management. When I was just listening to you, I really found a very beautiful message in one of the rules that you have emphasized. A simple message, but very powerful, that protecting water bodies by not throwing plastic. It's a great initiative toward preserving aquatic life and ecological balance. We really appreciate you that you have really guided us and you are connecting the traditional practices with environmental sustainability. So I hope we have any questions. We can go ahead and we have Dr. Tarun Das sir who can answer to us. Otherwise, we'll move to the next participant.
So thank you everyone giving me the opportunity and share my studies. Though it is an I'm like some of the I'm like few to some process this study. So and thank you organizer and all the audience those are listening my lectures and so thank you everyone.
Thank you, Dr. Das. And do we have any questions or we can move to the next participant here? Beautifully explained here.
Yeah.
We can
Shall I
stop
close,
sharing
madam?
the screen. Yes, yes. Thank you. So
Thank
do we
you.
have Mohit Biju, sir, postgraduate research
Hello.
student from
Yeah.
University of Plymouth?
Yeah. Hello. I'm here.
Good evening, sir. Please be
Yeah,
ready
good
with your
evening.
presentation. You can certainly go ahead and enlighten us on innovative disease diagnostic and control of soil-borne pathogens in daffodils. Is it the same daffodil, the beautiful flower? Are we going to discuss that you are going to help us understand?
Yeah, we'll be discussing about the daffodils, but we'll be mostly focusing on the family of the narcissus flowers. Yes, I'm just trying to share my window here. All right. Is my screen visible for everyone?
Yes, sir. It is visible.
Yeah, so this is just a very shortened title that I've come up with for the conference. The actual title is a bit more bigger, but just shortened up a bit for better understanding by everyone. So we are doing it in collaboration between the University of Plymouth and Rothamsted Research at Harpenden. So I'll be giving a very short talk on about the study that we are conducting here, and later on about the relevance of this study in terms of India. So I will start with some background to the narcissus farming here on the Isles of Scilly. So the narcissus farming, it started around the 1870s on the Isles of Scilly, and the Isles of Scilly are actually a group of islands which are about 50 miles away from the British mainland, and it is located in the Atlantic Ocean. So at first, the farmers were growing the daffodils in really small plots of the lands, and they were focusing on other things. So they were mainly doing dairy farming, they were growing potatoes and vegetables. But when they got into, hello, sorry.
Sir, are you there? Yeah, screen is not visible. Slides are not visible. It is showing you are present, but slides are not visible.
For me, it is in the sharing mode, so I'm not really sure what the issue might be.
Current window.
Sorry?
You have shared your current window. You need to share that PPT file.
Just a minute. I usually do these on Zoom, so it's I'm not really used to Google Meet, so just entire screen. Yeah. Is it visible now?
Yes, sir. Right.
Yes, it is. Yeah. All right. Thank you. Thank you for reminding me about it. Thank you. So I will just repeat a little bit and go back to the background part. So
can you please minimize that screen? Another screen is coming there.
This one?
Yeah. Can you minimize that or close that? Yeah, there is option to minimize. Yes. Yeah. Yeah.
All right.
That's okay.
Is it visible now?
Right. 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 Yes.
All right. All right. So we'll start with some background and go on talk about the study that I'm doing here. And later on, I will talk a bit about the relevance of the study in terms of India. So starting with the background, so the narcissus farming started around the 1870s on the Isles of Scilly. And the Isles of Scilly are actually a group of islands which are about 50 miles away from the British mainland, and it is located in the Atlantic Ocean. So they have like a different environmental conditions there compared to the mainland UK. So at first, the farmers there, they were growing the daffodils in really small plots, and they were mainly focused on other things like dairy farming. They were growing potatoes and vegetables. But when they got to know that the price of these flowers, they are really good in the London markets, they gradually shifted more towards the growing of these flowers, and they increased the production of daffodils. And by 1970s, the inhabitants of the Isles were mainly focusing on the narcissus as their main source of income. And the significance of these flowers can be clearly seen by their presence on the crest of the Isles of Scilly. Here it's there on the top left in blue. And later on in the shield of the Silonian tree, which is the main mode of transport between the Isles and the mainland. So the total retail value of the industry associated with the daffodils in just the southwest part of UK, called the Cornwall, is around 100 million pounds. And they also make a great contribution to the treasury of His Majesty in terms of the VAT, and that's on an annual basis. So the data says that it's around 20 million pounds per annum. And the narcissus, they are mainly affected by fungal and nematode pathogens. And to give you an idea about the losses happening because of them, smolder, which is a fungal pathogen, also known as Botrytis narcissicola, alone causes about 10% loss of yield per annum. And the farmers there on the island, they are mainly relying on chemicals as of now, and we are trying to find sustainable alternatives for them. So the importance of this study, coming on to that part. So as a part of the study, we'll be cataloging the cultural practices. And the reason why we are doing this is because these islands, since they are located away from the mainland and they have specific conditions like everything that needs to go on these islands, they need to be transported by a ferry or else by a flight, which means additional costs. And they also need special permits. The islands are owned by the Duchy of Cornwall, so you need permits from them on regarding what they are growing there. So they are not allowed to grow genetically modified organisms there at all. And they also have different environmental conditions compared to the mainland. So due to all these factors, they have come up with their own practices. So we are just trying to catalog them as in like how they have been trying to manage the issue with the nematodes or fungal diseases, or what all they are trying to do there. And then we'll be trying to relate them to the present day, how they have evolved over time, over the centuries. And we'll be also linking the presence of specific pathogens with the variation in the soil parameters by linking soil health and disease diagnostics. And we are doing all of this by collaborating with the stakeholders there. So we have a cooperative there called Mainland Marketing. So we have a collaboration in effect with them, and also with the farmers there. So what it does is that it helps us understand their challenges in a better way, and it also adds relevance to their solutions because they are a part of the team that came up with these solutions. So the focus for the study is on sustainability, and the methods that we are using as a part of the study, they're applicable to other crops. So it's not just limited to daffodils or just bulbous crops, but it is also applicable to a wide range of crops. And this study, it aligns with UN Sustainability Development Goals like 3, which is good health and well-being, 12, which is responsible consumption and production, and 15, life on land. So as a part of the study, we'll be coming up with certain recommendations that we'll be giving on to the farmers. So that's just part of the RISM, and we are trying to come up with some funds for the PhD to see if we can do some field trials for these interventions that we'll be coming up with. So what these interventions will do is that it will help in long-term disease control and soil health improvement. So now coming on to the research questions that we have is, does the cultural knowledge really have any sort of significance in designing plant health interventions? And can we identify what are the the permissive soil conditions that are allowing the presence of certain diseases, and what really underpins the varietal difference. So something that we have got across while interviewing the farmers is that certain varieties, like the yellow colored daffodils, they are more prone to diseases, and the white ones are a bit more resistant. So what really causes these disease susceptibility issues. And the methods that we are using to cover all these questions are interdisciplinary. So we have a social sciences part, as a part of which I completed ethics approval here at the by the POS system here at Plymouth. And after that, I got some questionnaires that was targeted for both cultivators and non-cultivators. So from the cultivators, we wanted to gather some idea about how they wanted to contribute to the study, and if they were willing to give us the fields for our experiments, and in what all way can they be a part of this project. And from the non-cultivators, we were trying to gather some idea about if they were aware of any sort of cultural practices before that is not being practiced right now, or some sort of community events that they used to have there, like flower shows or something like that. And also wanted to get some idea about the importance of these flowers to the inhabitants of the islands apart from the cultivators. So how does it really affect the non-cultivators there living, on the local people that are living on these islands? And we have also completed soil sampling to have a look at the physicochemical properties. So I did some R coding to pick up some spatial samplings, and based on which we did some sampling recently. And based on that, I also did some analysis like XRF, MIR, and loss on ignition. And in molecular biology, we have LAMP diagnostics to help us accurately identify the fungal and nematode patterns there. And yeah, we are coming up with a list of interventions to see if we can establish a long-term disease control and soil health monitoring system there. So just to give you an idea about the framework that we have for this project. So the important areas they cover are molecular diagnostics, soil ecology, and social sciences. In the pictures, you can see me out there in the field and also in the lab. And on top left, you can also see a screenshot, a picture, an image of a LAMP result showing positives for samples that we collected. And these are for nematode pathogens. So these are some preliminary results that we got from LAMP. So we made an initial first visit where we were mainly focused on gathering information regarding the location of these fields and the conditions, and also for the distribution of questionnaires, so that we can shortlist our participants for interviews. So I'm currently running the main LAMP test right now. So we had collected around 132 samples from different fields, and I'm currently running them right now. So it will take me a bit more time to share the results of that. But yeah, I've completed the soil-related tests, and I'm just working on compiling them. So I just completed them this week. So the outcomes of the study. So these are like the ones that we have completed, and the future outcomes as well. So based on the data that we have got, we will be trying to establish a correlation between the soil factors and the plant diseases. And we will also be evaluating the effect that these cultivation methods have on the soil factors. So as a part of the interview, we have been collecting information about the cultivation methods practiced by different farmers. So based on that, we'll be trying to correlate that with the soil reports and also with the LAMP reports. So that will give us an idea about the effect that these cultivation methods have on the soil. And the LAMP-based molecular diagnostics that we have got here, we used to earlier use it for mainly for marine biology purposes, to try and see if anyone was selling restricted fish species. But it's fairly recently that we started to use it for diagnosing plant diseases. And apart from that, we will also be evaluating methods like the ASD, which is anaerobic soil disinfection in the UK environment. So it hasn't been tested out in the UK environment as of yet. So we want to do as a part of this project, but we are still waiting for some funds to come in to start a proper PhD on that. It has already been practiced in Europe by Spanish farmers for flowers. I don't really accurately remember the flowers that they were testing it on, but it has been tested in Europe, but not really in the UK environment. So what value are the stakeholders getting from this study? So they are getting reports that will help them identify what sort of pathogens are there in their fields that are affecting these crops. And they will also be getting data regarding what are the soil parameters that they need to work on, if they need any sort of amendments or not. And we will also be documenting these practices and also be gathering data that will be very much relevant to the horticulture industry. So as a part of the study, we had noticed that there was a sort of a knowledge gap existing in that area. So that will be just filling up that gap. And they will, at the end of the study, hopefully they will have a sustainable disease control method, which will also help them improve their soil health. And these are everything that's the scientific value and the stakeholder value, but I will also be gaining a bit of value myself. So in terms of the personal value, it will be preparing me for a career in translating scientific knowledge into practical effects. So that will be really handy, and it will also improve the career prospects because of the interdisciplinary experience. And in terms of the relevance of the study for India, as you know, India is a country with very rich culture. And if you were to implement a similar interdisciplinary framework focusing on the stakeholders, but mainly keeping the focus on the farmers, it will help us come up with sustainable cultivation methods. They would also be having a cultural acceptance, because it is a thing that I've often noticed that we might come up with some solution, but it might not be what the farmers might have been expecting. So we need to meet the expectations, and to meet the expectations, it's really good to have them as a part of the team. So it will make it an easier process, and it also adds a really good value to the research as well. And yeah, by doing this, we will be improving the conditions of the farmers in our country, and we will also be helping the environment and also be promoting science on different levels. So this is the project team that we have. So that's me on top, and Dr. George is my director of studies. So he's an associate professor with experience in fungal biology. And Dr. Claire, she's a senior research fellow. She's the person who's helping me with the social science aspects. So yeah, Dr. Claire and Dr. George are both from the University of Plymouth. So we also have collaborators from Rothamsted Research, which is a private research organization. So we have Dr. Alice, who's a special statistician, and Professor Paul Harris and Dr. Alice Milne, who are from Rothamsted Research. So we also have collaborators there on the Isles of Scilly, the scented nast side, which is also known as the Blue Box Flower Company. So they are a cooperative of the farmers there on the islands, mainly on the St. Mary's Island. And we also have a collaboration in effect with the Isles of Scilly Museum. Miras, so that's just like a thank you, but in the language that we have here in Cornwall. It's a thank you basically in Cornish. Yeah, so if anyone wishes to collaborate with me or wishes to establish some sort of network, so yeah, they can just send me an email and get in touch. So that's my professional email ID and also my personal email ID. And if you wish, we can also get in touch by LinkedIn. Yeah, that'll be all. Thank you.
So we are truly glad to see you and your strong commitment on the road of sustainability, Mr. Mohit sir. Really, we are giving us a responsible innovation. Your efforts are inspiring us to move forward with a purpose and protecting nature while progressing towards a better future. So can we move ahead, or if anybody has a question?
I would be really glad to take any questions if anyone got it.
I think there are no questions, but once again, congratulations. It was a great presentation that we all could learn. Now, next we have Pallavi Patra from Jharkhand Rai University. She's a PhD scholar and she is going to tell us on cowpea as a living mulch in conservation agriculture, impacts on soil health, weed suppression, and cereal productivity in semi-arid tropics. So, do we have Pallavi Patra, ma'am?
Yeah, good evening, everyone.
Good evening,
I'm
ma'am.
sharing
Welcome.
my presentation.
Yes, certainly, ma'am.
Respected all the participants, really important announcement. I request participant to please take only the 7 minutes
I think my
as time is
presentation
running.
is visible.
Yeah, it's visible, ma'am.
Okay, thank you. Good evening, everyone. I'm Pallavi Patra, PhD scholar in agronomy from Jharkhand University. Today, my review topic, cowpea as a living mulch in conservation agriculture, impacts on soil health, weed suppression, and cereal productivity in semi-arid tropics. This presentation focuses on how cowpea living mulch systems can improve sustainability, productivity, and resilience in cereal-based cropping system. Here is a table of contents of what I am going to talk about today. First, coming to the introduction, modern agriculture has significantly increased food production. However, excessive tillage and chemical improves have degraded soil health. Soil erosion, nutrient depletion, and declining organic matter are global major concerns. Sustainable agricultural practices are therefore essential. One promising approach is the integration of living mulch systems into conservation agriculture. Among different living mulch crops, cowpea shows excellent potential due to its adaptability and nitrogen fixation ability. The objectives of my study are to explain the role of living mulch in conservation agriculture systems and its importance for sustainable crop production, to evaluate the potential of Vigna unguiculata as a living mulch in cereal-based cropping systems of semi-arid regions, to assess the effects of cowpea living mulch on soil health, including fertility, organic matter, and moisture conservation, to analyze the impact of cowpea living mulch on weed suppression and cereal productivity, to identify the management practices and limitations of the successful adaptation of cowpea living mulch in conservation agriculture systems. First, coming to conservation agriculture, it is based on three fundamental principles. First is minimal soil disturbance, second, permanent soil cover, and third, soil diversification. These principles improve soil structure and enhance nutrient cycling. Conservation agriculture also reduces soil erosion and increases water use efficiency. Living mulch systems strengthen these principles by maintaining the continuous vegetation cover over the crops. Next, the living mulch. What is this living mulch? It refers to the practice of growing a cover crop simultaneously with the main crop. Unlike the conventional mulches, living mulch remain biologically active. They interact with the soil microorganisms and improve soil fertility. Living mulch provides weed suppression, moisture conservation, temperature regulation, improved soil structure. However, proper management is necessary to avoid excessive competition between the living mulch and the main crop. Next, coming to the crop which I have chosen as a living mulch, that is cowpea. It is a warm season crop which is widely grown in tropical and semi-arid regions. It is highly tolerant to drought and heat stress. It can grow well under temperatures between 25 and 35 degrees Celsius and under rainfall conditions between 400 to 1000 millimeters. The crop has a deep root system which allows access to subsoil moisture. Cowpea forms a symbiotic association with the rhizobium bacteria and fixes significant amount of nitrogen. Nitrogen fixation, which improves soil fertility and reduces this synthetic fertilizer requirements. Next, how this living mulch performs with cereals. Cowpea is widely intercropped with cereals like maize, pearl millet, sorghum, rice, etc. So, interseeding of cowpea approximately 7 to 14 days after the sowing of cereal crops minimizes the competition between both the crops. Research studies show significant yield benefits. Cowpea improves this nitrogen availability, which enhances the soil moisture retention and improves the cereal productivity. Next, its impact on soil health. Cowpea as a living mulch improves the soil health by increasing the soil organic carbon, reducing the shedding effects. The soil temperature, which is reduced due to its shedding effects. Lower temperature improves microbial activity below the soil. Bulk density decreases, improving the soil structure. Next, microbial biomass increases due to the organic inputs, that is because of this living mulch. This improved things or these improvements contribute to long-term sustainability. Next, its impact on weed suppression. Weed control is a major challenge in cereal production. Cowpea it provides effective weed suppression. Dense canopy reduces light penetration. Weeds cannot germinate easily. Cowpea competes with the weeds for nutrients and water. And some studies show or indicate that there are allelopathic effects on the weeds because of cowpea. The weed biomass therefore reduces up to 80%, which has been shown, which has been studied in several research papers. Next, coming to the climatic benefits of cowpea as a living mulch, it contributes to climate-smart agriculture. Soil carbon sequestration increases, improved soil structure enhances water filtration, reduced tillage lowers carbon emissions. Living mulch systems improve the drought tolerance. These systems help stabilize yields under climate variability. Then coming to the economic benefits of the living mulch, economic sustainability is the most important thing that a farmer needs. Living mulch systems reduces the production cost, fertilizer requirements, herbicide use, labor requirements of weeding. So therefore, it increases farmers' profitability. And studies indicate that the returns over inputs increases from 20 to 50%. These benefits are particularly important for smallholder farmers. So my research or the review papers which I have studied, from there the findings are: soil organic carbon has increased due to the use of cowpea as a living mulch in several years. Nitrogen fixation averaged between 50 to 100 kilograms per hectare. Weed biomass decreased up to 80%. Soil moisture increased. Cereal productivity is improved. These results demonstrate that the sustainability of cowpea living mulch systems. Now, there are several limitations of living mulch also, despite the advantages that we have talked about. Competition for water and nutrients may occur. Poor management may reduce cereal yields. Living mulch require proper timing and density control. So they may also harbor pests. Performance varies under climatic conditions. Now, limitations of cowpea as a living mulch. Cowpea as a living mulch also face many constraints. Those are early competition may reduce cereal yields. The cowpea biomass production decreases in intercrops. Nitrogen fixation is reduced in phosphorus deficit soils. Cowpea is susceptible to pests and diseases, and harvesting becomes difficult. Harvesting may face difficulties due to its fine growth. Next, the general management principles for any living mulch. Proper management is very essential for success. The seeding time, the seeding rate, the variety selection of what variety of living mulch we are selecting, what fertilizer we are using, and we shouldn't use, means we should avoid excess use of nitrogen fertilizers, especially during the early growth time. Next, what management should be done if we do cowpea in a living mulch system? We should do minimum tillage. Proper spacing should be done, timely sowing, monitoring crop competition. Termination methods may include grazing or mechanical removal, and these practices ensure the optimal performance of cowpea as a living mulch. In conclusion, cowpea living mulch improves soil health and fertility, with suppression is highly effective. Cereal productivity increases, climate resilience improves, economic returns are favorable. Cowpea living mulch is a promising strategy for sustainable agriculture. Next, coming to the future prospects, it focuses on region-specific management practices. Long-term soil studies should be done before planting any living mulch or before planting cowpea. Improved cowpea varieties should be planted as a living mulch. Integration with other cover crops may also be done. And genetic improvement may enhance biomass production and drought tolerance more, as it is doing now. Next, recommendations include development of location-specific protocols. Farmer training programs should be conducted, extension support should be there, policy support for conservation agriculture should be made, and these steps will enhance the adoption of cowpea as a living mulch. Here is the reference from where I have taken my studies. Thank you for this opportunity. If anyone has any questions, I'm available to answer.
Well, thank you so much. Very beautiful presentation by Pallavi Patra ma'am. Really, you are encouraging sustainable farming in an eco-friendly and agriculture practice, which is really protecting our biodiversity and ensuring a long-term soil health for future generation. Thank you once again. So if anyone has questions, we can take up, else we'll move to the next speaker. Since no one has a question, let's move on to the next speaker, Tanima Pal, a PhD scholar, IARI, New Delhi. Do we have here? Ms. Tanima
Yes,
Pal?
ma'am, I am here.
Okay, welcome. So, your presentation is on biochemical and psychological effect of nanopriming on seedling vigor of rice. Can you please share the PPT?
Is it visible, ma'am?
No, we cannot see it.
No, your PPT not visible. Please share it.
Is it visible now, sir?
No. Ma'am, please share the screen.
Sir, is it now visible?
Now your screen is shared, and now, yes, now your PPT is visible.
Good evening, everyone. Welcome to the state authorities, analysts, business, and contribution by I am going to present my master's research topic. Yes. And those that slide should be
Sorry to disturb with Tanima ma'am. Pallavi ma'am, can you hear his voice clearly?
No, we are not able to hear Tanima ma'am. Kindly come into the network. We are not able to hear any of your presentation. We request Tanima ma'am to please come to the network and try sharing the PPT.
now I'm hello.
Now we can see the PPT. If you can speak a little about it.
Ma'am, am I audible now?
Yeah, now it is better. Thank you.
Okay, thank you.
Yes, ma'am. Yes, ma'am. Now it will. You can go ahead.
Okay, sir. So I'm starting from the current slide. So nanoparticles are type of particles which are engineered in such a way that the particle size should be within nanoscale range. And mostly it is used so that this metal or metal oxide based nanoparticles can penetrate inside the cells or tissue of the plants and for the betterment of the plant growth development as well as their immunological pathways. And priming is used as one of the strategies to introduce the nanoparticles within the plant tissue. And also in my study, we are focusing on the seedling vigor because mostly our main motto is increasing the yield potential, but seedling vigor is one of the most important part of the plant life cycle. If it is overall health, strength, and the growth potential is okay, then it will lead to a potential yield. So our laboratory has been working.
We cannot see your presentation now. We can hear you, but we cannot see the slides that you were showing now.
Okay, ma'am, you can. I am sharing. Is it visible now?
Yes, now it is visible. Yes.
Okay. So our laboratory has been conducting the research on green synthesis of nanoparticles, like based on the botanical extract with nanoparticles. And previously, green synthesis of this SNPT, that is silver nitrate turmeric rhizome extract nanoparticle, has been characterized, and its potential on retardation of Rhizoctonia solani was observed up to 80%, along with upregulation of phenylalanine ammonia lyase activity as well as PR protein gene expression. So, according to understanding the previous literatures in our work in continuation, we have set our objective to understand the phenotypic effect of nanopriming on rice plant and yield, biochemical changes within the seedlings after priming, as well as impact on the plant gene expression. For conducting the research, these are the step-by-step methodologies by which we have done our research. First of all, two botanical extract-based nanoparticles we have used. First one is from turmeric, that is SMPT, I have already discussed. And second one is from cinchona bark. And from cinchona bark, two type of nanoparticles. One is chitosan-based, another is iron-based. And thereafter, we have done seed priming in rice and growing in field condition, considering the related parameters, phenotypic and biochemical parameters, as well as done in vitro study. Thereafter, going to antioxidant enzyme activity and transcriptomic profiling. So nanoformulation has already formed. We can be ensured by three methods. First primary one is UV spectrum analysis, where we can see the absorbent peak range should be at its recommended one. That is, for SNPT it should be at 425 nanometer, for ICNP should be 290 nanometer, and for CCNP it should be at 320 nanometer. Thereafter, the size of nanoparticle should be considered as it is in nanometer or not. And as we can see for SNPT, the smallest size of nanoparticle can be found in within the concentration of 200 nanometer. That is within 100 nanometer of the area. For CCNP, ICNP, it is quite larger than that. As well as morphological study and the elemental composition of all of the particles like carbon, nitrogen, oxygen of the botanical extract, and the metal ions like iron for ICNP and silver for SNTP has been present there. We can study that by FESCM and EDX study. We have found out there is all type of particles present within the nanometer range. Later, we have done the field evaluation, and by periodical observation at 3 times, like 2 times in seedling stage as well as in yield harvesting stage, we have studied different listed parameters. And here is and also we have selected 4 rice varieties for our research. That is Uttar Sona, Uttar Ganga, Kalamunia, and Swarno. Swarno is the mega variety as we know, and Kalamunia is one of the aromatic rice. And Uttar Ganga and Uttar Sona was released by UPKV, and we wanted to study these 4 varieties here. And as visually we can see, all of the nano treatments have better biomass production, better plant height, number of leaves, number of roots, root length, root biomass, everything compared to the control ones. By graphical analysis and principal component analysis, we can see, except Calonuria, all other 3 varieties have shown positive impact for all of the parameters on all 3 of the nano treatments, and all the traits are getting negatively correlated with the control ones as we have expected. And SNPT is exhibiting the best result on vegetative growth, root figure, root architecture, etc. CCNP solely impacts on the yield-related attributes, and ICNP has moderate but balanced impact on both the vegetative growth as well as yield-related attributes, along with the chlorophyll content. Then the same study we have done in vitro condition, for as Calonuria being unresponsive and Uttar Ganga being the less potency variety, we have discarded them and studied on Uttar Sona and Swarno at 3 days and 5 days after germination, and we can see for root length, all of the treatment, mostly ICNP and SNPT has shown the significant impact for both of the periodical observation, and both shoot length and root angle increment has been potentially observed and notably increased in case of Uttar Sona. That's why further for biochemical parameters, we are experimenting on Uttar Sona variety. So, as an external particle has been introduced, so nutrient mobilization can be should be there to going for the nanoparticles inside plant tissue. So nutrient mobilization is directly proportional to the ROS accumulation. For determination of ROS accumulation, we have studied based on the staining as well as microscopy in nanoprimed root tip compared to control one. For that, 2 type of assay have been done. DCFH DA assay has been done for understanding how much total ROS accumulation is there, and studied under fluorescence microscopy as well. NPT staining has been done to understand only the superoxide radical accumulation, and studied under bright field microscopy. Here we can see for all of the treatments, there is mean fluorescence intensity is more than the control, but significantly more accumulation has been shown in ICNP and SNPT. That's why we have studied the antioxidant enzymatic assay for these two treatments, because if the ROS accumulation is good, but if it is going beyond threshold level, it is hampering the plant growth and other development strategies. So here the four enzymatic assay has been done, and for all of them, the antioxidant enzyme activity has been shown more for treated ones than the control ones, but the most significant impact shown in phenylalanine ammonia lyase and catalase. Thereafter, we have done RNA sequencing or transcriptomic profiling, comparing the SNPT prime seedlings with the control ones. And here in heat map, we can see 512 number of genes have been upregulated and 1110 number of genes have been downregulated. And thereafter, considering the threshold level of fold change more than 2 and p-value less than 0.05, we can see that 108 number of differentially expressed genes have been upregulated and 357 has been downregulated. And through the volcano plot, we can see there is no significant correlation among the upregulated and downregulated one, as there is no overlapping. Coming on to the gene functional annotation. Here we can see the highest fold enrichment have been found out in alpha amylase activity, followed by starch catabolism and diterpenoid biosynthesis. Coming into the phylogenetic tree analysis, we can see the three gene functional annotation: biological process, molecular, as well as cellular location. For biological process, mostly secondary metabolites like diterpenoid terpene biosynthesis has been shown, as well as the carbohydrate metabolism like disaccharide sucrose starch metabolism. For molecular function, we can see the hydrolase activity, the carbohydrate metabolic process, alpha amylase activity has been increased, and for cellular location, only the extracellular region has been considered. Coming on to the gene protein interaction, here we can see the three main network has been shown. One is considering the carbohydrate metabolism, another is considering secondary metabolites, mainly diterpenoid and terpenoid biosynthesis activity, another considering the disaccharide metabolism and biosynthesis activities. So, for understanding the enzymatic pathways and how these genes are involved in any pathway that can actually considering later developmental as well as stress-related pathways, we can see that there is 6 major pathways have been identified, having most fold enrichment in diterpenoid biosynthesis, followed by starch and sucrose metabolism. After considering all type of gene expression has been found out, and with the validation of qRT-PCR, we can categorize them in four classifications. First of all, growth and developmental pathway involving cell wall modification, organogenesis, embryogenesis, root and shoot architecture, transportation of the sugar and silicon, as well as fat biosynthesis. And thereafter, for stress, I didn't do it in biotic and abiotic stress, but in two different classification, like different plant growth regulator signaling pathway that is having correlation or the association with the abiotic stress tolerance, like biosynthesis of secondary metabolites, different toxins like phytoalexins, phenylpropanoids, etc., that is giving onto the hypersensitive response as well as systemic acquired resistance. Also, other biotic and abiotic stress difference associated genes. Other than that, we have found some other cellular activity that is related to lipid transfer, related to chloroplast function like 50S ribosomal protein, as well as nucleotide pyrophosphatase and RNase. Considering all the research work, we can conclude here that nanopriming enhances the seedling figure with increased plant height, tiller number, other phenotypic parameters. Synchronous nanoparticles are solely focusing on the yield-related attributes. SNPT has positive impact on seedling establishment, but showed slight toxicity effect on the plant. We are considering it is because of the higher concentration we have used. As well, nanopriming induces the ROS accumulation, which helps in effective nutrient mobilization later on, and the aggravated level of ROS so that they doesn't go beyond the threshold level. So ROS scavenging activity has been identified properly in significant level. As well, RNA sequence analysis proves that SNPT acts as an elicitor to the plant, which mediate defense response to the plants against any type of stresses. So activation of defense signaling pathway may contribute to the development of innate immunity of plant, resulting in the strong and resilient seedlings. So in future, we can study for the betterment of the effect or potential of nanoparticles in this way, like study combinatorial effect of different nanoparticles or effect of nanopriming on polarized cultivar, as we have studied only on kharif. Then variety-specific study, trial on other economically important crops like wheat, barley, potato, etc. as well, which are facing the seed dormancy or late seed germination problem. So lastly, I like to acknowledge all the organizing committee members, my honorable Vice Chancellor of UVKB, Director of Farm, my advisor, faculty members, as well as lab mates. So thank you for your patience and listening to me. Thank you.
So thank you so much, Tanima Pal ma'am. It was an excellent presentation on biochemical and psychological effect. We definitely look forward for more inputs in future from you, and we all really appreciate the hard work that you have done behind doing this research work, and your presentation was amazing. So if we don't have questions, can we move to Sarita Kumari, Assistant Professor and PhD Research Scholar?
Yes, ma'am.
Do we have Sarita Kumari from Pune Mahila Mahavidyalaya?
Yes, ma'am. Yes, ma'am.
Welcome. You are speaking on musculoskeletal disorder and perceived exertion among makhana processing women workers of Darbhanga district, Bihar. So, do we have your presentation ready?
Yes, ma'am.
All right. So,
Can I share my slide?
definitely. Please share your slide.
Yes, ma'am. Thank you. Thank you, ma'am, for inviting me. Myself, Sarita Kumari, today Assistant Professor, Purnia Mahila Mahavidyalaya under Purnia University, and PhD Research Scholar from MPAT Udaipur, Rajasthan. Today I am going to representing my research work topic on musculoskeletal disorder and perceived exertion among makhana processing women workers of Darbhanga district, Bihar. Makhana processing is a highly labor-intensive, traditional and mainly manual activity centered in Bihar, India, involving various activities like storage and collection of seeds, cleaning of seeds, sun drying, grading, preheating, tempering, roasting, followed by hammering and packaging to produce a popped makhana. Despite being a highly nutritious, organic, and valuable aquatic crop, its processing continues to rely heavily on traditional methods, resulting in significant exertion, musculoskeletal disorders, and various ergonomics problems. The objective of the research study is analysis of work-related musculoskeletal disorder and perceived exertion among women workers involved in makhana processing activities. The research was conducted in Manigachi block, Darbhanga district, Bihar, which was purposely selected due to the high involvement of women in makhana processing activities. A snowball sampling techniques was used to select 40 women workers engaged in makhana processing activities. They having a minimum of 10 years of experience in makhana processing and willing to participate in the study. Primary data were collected through the structured interview schedule focusing on musculoskeletal problems and disorders and perceived exertion experienced during work. The time period of research is 2019 to 2022. The tools and techniques used for data collection is first is work-related musculoskeletal disorder among women workers using 4-point modified continuum scale was used. There zero is no pain and 1 is mild pain and moderate is 2 and severe pain is categorized under 3 to the calculate intensity of musculoskeletal pain and perceived among workers. The rating of perceived exertion was the second tools on the basis of rating scales of perceived exertion. Subjective rating of feeling of tiredness was categorized as follows as a modified rating scales of perceived exertion developed by Verghese 1994 based on Brock's 10-point scales is 1982 was adopted to measure the perceived exertion in terms of very light, moderately heavy and very heavy for 1 to 5 for assessing the perceived exertion. These images shows that the first is participation of women workers in makhana processing activities. They are involved in roasting and popping activities, and there are various activities. And the second figure shows the final process makhana. So in this makhana processing, the women workers and also male workers faced so many ergonomics problems because all activities are very dangerous prone and giving our musculoskeletal problems, health hazard, etc. And the result was the study is distribution of women workers according to perceived exertion in makhana processing activities. The majority of respondents, 95% perceived a popping activities was very heavy, followed by 92.5% who considered storage of seeds to be also very heavy. In contrast, only 12.5% of respondents perceived packaging activities was very light. It was evident that popping activities was ranked first and followed by storage of seeds under rank second, and the minimum rank found in packaging activities is rank 10. And the second table shows that the percentage distribution of musculoskeletal pain among the women workers, the highest proportion of respondents, 85%, experience in severe pain in knees, followed by 75% in buttocks and 62.5% in lower arms and 52.5% is mid back and so on. And these under moderate pain, the highest percentage of pain found in neck, followed by 82.5%, followed by shoulder 75%, upper back 72.5%, and various categories shown in table. And the minimum percent is mild pain find in 2.5% in upper back, followed by 5% in shoulders, and then upper arm, then lower back, and then mid back. In Conclusion of this study is women involved in makhana processing on a daily basis were observed to adopt different awkward postures while performing various sub-activities, among which popping was perceived as a very light activity. Prolonged maintenance of such an awkward posture lead to discomfort in different body parts and results in a pain in knees, neck, buttock, shoulders, and other areas, thereby increasing the risk of musculoskeletal disorders and perceived exhaustion among these women. Therefore, the ergonomic intervention is essential to improve the postural health of the workers, enhance productivity and safety, reliability for working a woman in makhana processing activities. Thank you. Thank you all for giving me this opportunity to representing my presentation on this seminar.
Congratulations and thank you for focusing on health and occupational challenges which are faced by women in makhana processing. Your study is especially significant because we all know that Women's Day is approaching, and we really honor the strength and resilience and well-being of women workers. Thank you for giving such an inspirational presentation. So
Thank you, ma'am.
forward for the next presenter. So this was Ms. Sarita Kumari, who gave a beautiful presentation. Do we have Shivan Kumar Rajput, a PhD scholar from ICAR, Indian Institute of Horticulture Research, Bengaluru? Do we have him? He's the last participant of this evening.
Hello, good evening, ma'am. Hello.
Good evening, sir.
Yeah,
You are
I'm
giving a
Vishwanath.
presentation.
Yeah, ma'am, actually, I have tomorrow presentation. Shall I present, ma'am? Tomorrow, maybe I'm in out of station, actually. Maybe network issue will be there. That's why, shall I present, ma'am, now?
I request Sudhanshu sir or Bibha Kumar sir to please take a judgment on this, if this is okay.
Ma'am, we can take one presentation. If current person is absent, then we can allow this last one.
So this was the end of him. Anyone else who is remaining would like to take a last presentation? Else we'll move to the closing session.
Ma'am, shall I take, ma'am? Vishwanath. Hello.
Okay, sir. We can allow you. Ma'am, let's allow this presentation.
Kindly go ahead, sir. You can share your PPT.
My presentation is visible, sir. Hello.
Not yet.
No, I think.
One second. Yes.
Yes, visible.
No, it's visible, sir.
Yes, visible.
Good evening, all the dignitaries and also my fellow
Hello.
present. Hello. Yes, sir.
Sir, that was banner only. Your presentation is not visible.
Yeah, one second.
Are you trying in laptop?
Yeah, one second, sir. 1 second. Give me 1 minute. 1 minute.
I think you have shared another window
Yeah,
again.
one second. Just stop sharing. Mhm. No, it is visible, sir.
No, not visible. How are you trying using mobile or laptop, sir?
Laptop, sir, actually.
Then select share entire screen option. Yes, yes, it is visible now. And just go to that slide, that option.
Show my screen.
Yes, yes. Now go to presentation.
Yeah, now it's visible, sir.
Yes, and there is play button just near to zoom.
Yeah, yeah,
Yes.
that thing.
Thank you so much. Can you click over hide there?
Yeah,
Stop sharing and hide is mentioned on the screen here.
yeah. Now it's visible,
Thank you.
sir.
Yes, yes.
Yeah,
Good. Thank you.
yeah. Thank you, sir. Good evening, all the dignitaries and my fellow participants. I'm Vishwanath Vai from Amity University of Agriculture from Noida. My oral presentation on optimizing potato productivity through nano nitrogen and potassium application in the southern region of India. In the southern region, main potato production problem is that actually nutrient deficiency. Apart from that, very short span of availability actually for the cultivation actually, nearly almost 70 to 80 days is available for the compared to the northern India. Northern India, for cultivation of potato, almost cold will be there up to 120 days, 150 days. In the southern region, very short period of is there actually. So that within the short period, we have to enhance the productivity by application of some other nano fertilizers or any other fertilizer experiment. As we know, potato is a most uh, nutrient demanding crop, and also it's the most it's the most important crop for after the rice, wheat, and maize. And as we know that actually the potato is the more productivity and a more nutritional value as compared to the other crops, as compared to the other cereal crops. So that it requires the high inputs are actually, especially the nitrogen and potassium actually. For the nitrogen, why it is required means actually for the nitrogen, it's the main component of the chlorophyll content, amino acids and protein and nucleic acids, and it helps to increase the large size tuber. So the large size tuber will increase means the automatically yield of the any crop will be increased. Whereas in the potato actually, in the potato, potassium also plays a very important role, especially in the water content, maintaining the stomatal conductivity and also enzyme activity and cell expansion, target pressure regulation and cell water retention. All these patterns, along with that, in the processing potato, potassium plays a major role in increasing the dry matter content apart from the disease tolerance. We conducted our research of work in the Bagepulli in Chikbalapur district in the 2 years actually, 22 and 23, in the loamy soil, in irrigated condition. We have a number of treatments is 14, and we have replicated thrice with a spacing of 60 centimeter into 25 centimeter, and grass plot size of 6 meter into 5 meter, and net plot size of 4.8 into 4 meters. And this is the treatment details actually. The T1 is the control and T2 is the package of practice as per the US Basel Code, sir, actually, which is consists of 125 kg of nitrogen, 100 kg of phosphorus and 125 kg of potassium. Apart from that, 10 kg of iron sulfate and zinc sulfate. Along with that, FOM is common for all the treatments, 1.5 tons per hectare. And T3, T1, T3, T4, T5 is only the foliar sprays, sir. 1, 2, 3, and and T6, T7, T8 is the 24% of nitrogen along with the 3 levels of foliar sprays. And consequently, all the treatments like T10, 11, 12, all these 50% with 1, 2, 3 sprays. And T12, 13, and 14, it consists of 1 spray, 2 spray, and 3 sprays, sir. This is the time of application actually. The in that POP actually, we have nitrogen we have applied at 50% at planting and 50% at earthing up. All these in phosphorus we have applied 100% at the basal itself actually. In potassium we have followed the same trend as in the nitrogen. Whereas in the all the treatments also we have followed the same trend. For example, we have almost T14. For example, we have applied only the for T14 we have applied only 75%. Out of that we have applied only 37.5 kg of nitrogen and remaining at the earthing. We have split it into two actually, two times. One is at the basal and one is at the earthing up time. And the entire dose of phosphorus is applied at the planting itself. This is the quantity of fertilizer applied during the different intervals, sir, actually. For example, when we compare with the planting, actually, we have applied almost 46.87 kg of nitrogen in the T14 in compared to the T2. That's the package of practice, 62.5 kgs. In the same trend was followed in the earthing up region also. For the first spray, we have used almost 325 ml of in the 325 ml of liter water we have used with the volume of 975 ml of this one, sir, nitrogen, nano nitrogen, and also nano potash. Nano potash is taken from the, as we know, nano nitrogen is taken from the IFCO company, consists of 4% of nitrogen and also 4% of nitrogen, whereas in the nano potash, nano biopotash, it consists of the 9% of potash along with the 6% of amino acids, so that it can, apart from the supplying the potash, and it also helps in increasing the vegetative part, so that the leaf area, so that it can improve the productivity of the overall crop, sir. This is the results, sir, actually. Effect of nano fertilizers on plant height and also chlorophyll content at different growth stages. We can clearly observe the T14, sir, actually. There is a clear-cut difference is that 40.4 centimeters in the height actually as compared to the T13. That's T14 is the 75% of nitrogen plus 75% as potash and full dose of phosphorus with 3 foliar sprays is having recorded the higher plant height and also higher chlorophyll content, SPAT values as compared to the other POP and everything. But however, it is on par with the 2 foliar sprays, 75% of nitrogen and 75% of potash with full dose of phosphorus with 2 foliar sprays. It's on par with the highest treatment and also a POP. The same trend was followed in the number of marketable tubers, fresh yield per plant, and fresh tuber yield and biological yield. When we come to the economics of the potato, actually, when we compare with the all the treatments, T14, that is the 75% of nitrogen and potash, along with the 3 foliar sprays, has recorded the highest gross returns, almost 2,56,329 rupees, as compared to that's the 2 sprays actually. That's the 2,46,127 rupees. However, it is on par with the POP. That's the total overall gross returns of 2,35,591 rupees. However, highest BC ratio was recorded in the T14 itself. However, it is on par with the POP also. That's the 2.68 for the POP and 2.75 for the T14, sir. Actually, 75% of recommended nitrogen and potassium, along with the 3 foliar sprays. Coming to the conclusion, nano formulations based fertilizers have great influence on the crop growth and development by making available to the crop for relatively longer duration of time periods without losing the nutrient composition in them. The results of our study provide the compelling evidence that strategic nutrient management, particularly through the application of nitrogen and potassium alongside the foliar nano nitrogen nutrient application significantly enhances the growth and yield of potato. Future line of studies should be explore long-term impacts of such practices. Maybe it may degrade the soil health or subsequent crop cycles. Further establish the sustainable agriculture practices. The farmers can follow this kind of agronomic practice. They can save 25% of fertilizer usage. Along with that, they can improve the overall income of the farmers, sir. Thank you, sir. Thank you for your opportunity. Thank you all the dignitaries, sir. Any questions, please? Hello. Hello.
Thank you so much. We are truly honored to serve you over here. It was a very beautiful presentation given to you. And on a personal note, I truly feel honored to have served you as an anchor for today's prestigious event. Congratulations for the grand success of the conference. It was my privilege to guide you through the day's proceedings and to share this platform with such brilliant mind. I conclude the day 2 of NCAISLFI, and under the leadership of Sudhanshu Shekhar sir, 360-degree Research Foundation, I would like to make sure that lots of gratitude is to each and every eminent speaker who has come here, to the chief guest, to all the scholars, organizers, and for giving us such an expertise on truly enriched deliberation. Your contributions have really given a lot of encouragement to have a sustainable, beautiful future of India. Thank you so much, and we look forward to welcome you tomorrow with renewed energy, fresh ideas. And with this, we try to close today's session. Thank you for the amazing conference which was held. Thank you, each and every participant, each and every team who was behind this.
Thank you, ma'am. Thank you. Thank you for the opportunity, ma'am.